right? Hello everyone, welcome to concept series of the subject of discrete mathematics. Friends, the main objective of this concept series is we have to take high priority concept and we have to discuss that concept. Afterwards we have to solve some different kind of questions, right? So we have approximately 4 hours time slot today, so from 4 p.m. to up to 8 p.m. Let me explain how I'm going to plan this 4 hours time slot, okay, so that I can effectively utilize the time slot, friends. Okay, so my strategy is 4 p.m. to 4:45 p.m. I'll discuss most high priority topic is applications of combination with repetitions. You might have already seen previous paper GATE questions. There are so many questions that are rising based on the concept of application of combination with repetitions. That is the reason I have chosen this topic, friends. Okay, so I'll spend 45 minutes to explain the concept of applications of combination with repetitions, followed by we'll discuss some difficult questions based on the topic, friends, right? And the second one, 4:45 p.m. to 5:30 p.m. I chosen second topic is formation of recurrence relations. You know the importance of formation of recurrence relations, right? Because recurrence relation concept is most important for computer science branch, because we will study recurrence relation in various subjects like discrete mathematics, data structures, programming languages, and also followed by algorithm subject, right? So in every GATE paper we can see one question from the recursion concept. That is the reason I have chosen this topic, formation of recurrence relations, friends. Okay, so I will spend 45 minutes time and I will discuss most important questions in formation of recurrence relations, friends. Okay, after formation of recurrence relation we have to solve recurrence relations. Okay, but solving recurrence relation beyond the scope of the today class, because I already explained different kinds of methods, right? So please go through them. Next, third one, 5:30 p.m. to 6:30 p.m. I'm going to discuss types of relations. It is also most important area where you can expect one question from the topic, right? You know types of relations, right? Like reflexive, symmetric, asymmetric, antisymmetric, transitive, and equivalence relation, partial order relation, right? We'll discuss all kind of relations in this today class. Okay, not only that, we'll discuss different types of questions what they are asking frequently based on the types of relation, friends. All right, and the next topic is 6:30 p.m. to 8 p.m. that is propositional logic and first order logic. Here I'm going to discuss some important shortcut methods, friends. Okay, so this session is very much important for you because I'm going to discuss very important tricks. The moment if you see the question, you are in a position to answer the question. Okay, you no need to waste your valuable time for answering those questions. So I'm trying to discuss most important tricks for solving first order logic and propositional logic concept, friends. Okay, so I feel this slot 6:30 p.m. to 8 p.m. is most valuable slot for you. Okay, next 8 p.m. to 8:30 p.m. will take general suggestions for writing discrete mathematics in the GATE exam, friends. This is a plan which I made before starting the course. Okay, let me see the YouTube comment box, chat box first. Okay, let me see how many of them are. Let me see any general questions are there or not. Afterwards we'll discuss first topic is applications of combination with repetition, friends. Right? Yeah, good evening to one and all, friends. Right. Let me start. The first topic is applications of combination with repetition concept, friends. Okay. The first important application is find number of non-negative integer solutions find number of non-negative integer solutions for the equation x1 plus x2 plus up to so on xr is equals to n. So x1 plus x2 plus up to so on xr is equals to n. So it is one of the most important application. If you refer previous paper GATE questions, you can find more number of questions in this topic, friends. Okay, so let me explain this application first. Okay, for the time being you can take it is xn, friends. Let me take xn, which is equals to r. It is the first application. Find the number of non-negative integer solution for the equation x1 plus x2 plus up to so on xn is equals to r. So you can find problems like this, friends. How many non-negative integer solutions are possible for the given equation x1 plus x2 plus x3 is equals to 3? How many non-negative integer solutions are possible for solving this equation x1 plus x2 plus x3 equal to 3? So as the title suggests, is a concept series. First let me explain what is the concept behind this for solving this type of questions, friends. Okay, here the most important key point is they are expecting non-negative integer solutions. Non-negative integer solution means 0 also will be allowed, friends. Okay, we can take value of x is 0 also. So they are expecting non-negative integer solution means we can take choice of x1 or x2 or x3, either it may be 0 also, friends. Okay, let me list out all possible solution for this, friends. Afterwards we will discuss what is the concept behind this, right? Okay, let me list out all possible solutions. So suppose if I take values of x1, x2 and then x3, one possible solution is, friends, I can take x1 is equals to 0, x2 is equals to 0 and x3 is equal to 3. Now substitute those values here, we will get the result is 3, correct? So 0, 0, 3, that is one possible solution, friends. And second possible solution, we can take x1 is 0 and x2 is 3 and x3 is 0, friends. That is second possible solution, right? And another one is we can take here it is 3, 0, 0. So far we got 3 solutions, friends. Okay, we got 3 solutions. Let me take another solution starting with 1 here. So I can take it is 0 and it is 2. So 1 plus 0 plus 2, that equals to 3, right? So I can also take 1, 2 and then 0. It is another way of finding solution, friends. Okay, so what is the other way of finding solution? We can take 1, 1, 1 like this, right? So if I could start with 2 here, friends, 2, 1, 0, or else we can take 2, 0, 1. So in this way we are going to list out all possible solutions, friends. Okay. Now here problem is very simple problem. That is the reason we are going to list out all kind of solutions like this. Of course, few more solutions also possible here. But in the examination point of view, they'll ask x1 plus x2 plus x3 equal to 10. If they ask x1 plus x2 plus x3 equal to 10, then it is very difficult to enumerate like this, right? Now then, what is the concept behind this? What is the concept behind this? So please listen, what is the concept behind this, friends? It is nothing but distributing three similar balls into three numbered boxes. Distributing three similar balls into three numbered boxes. So how simple we can answer this kind of question, friends? So what we will do, you consider these three similar balls, place them on a floor. Let me take three similar balls like this, friends. These are three similar balls. Just place them on a floor next to each other. Okay. Afterwards, here number of variables we are having three variables. If there are three variables, you can take two vertical lines, friends. You can take two vertical lines. Okay. Suppose if I take two vertical lines, friends, here. If I take two vertical lines, right? So these two vertical lines will partition that line into three parts. So what are the three parts here? So number of identical balls which are left side of this vertical line, number of identical balls between these two vertical lines, and number of identical balls which are right side of second vertical line. Okay. Number of identical balls left side of first vertical line, if I indicate with x1, now x1 is equals to 0, friends, here. x1 is equals to 0. Number of identical balls between two vertical lines, if I indicate with x2, here x2 equal to 0, friends. Means there are no balls in this case. There are no balls. Number of identical balls right side of second vertical line, if I indicate with x3, so x3 contains 3 balls, friends. Means it is providing solution is x1 is equals to 0, x2 is equals to 0, and x3 contains 3 balls. This is a solution which they are providing, right? Number of identical balls which are assigned to x1 is 0. Number of identical balls which are assigned to x2 equals to 0. Number of identical balls which are assigned to x3 equals to 3, friends. Therefore 0, 0, 3 solution obtained. Suppose if I want to get 0, 3, 0, then how can I place these vertical lines? If I want to get 0, 3, 0, I can place vertical line like this, friends. So we are having three similar balls, right? Now place first vertical line here and second vertical line here, right? These two vertical line will divide or partition that line into three parts. Okay. Number of balls left side of the first vertical line indicated by x1. Number of balls between two vertical lines indicated by x2. Number of balls which are right side of second vertical line indicate with x3, friends. Right. Now see, in x1 how many identical balls are there? 0. x2 we are having 3 and x3 we are having 0. So we are getting this solution 0, 3, 0, friends. Okay. 0, 3, 0. Clear? Then how we are getting 3, 0, 0? Yes. So in order to get 3, 0, 0, what we have to do? Take three identical balls, right? Place two vertical lines here. Number of balls left side of first vertical line indicate with x1. Number of balls between two vertical lines indicate with x2. Number of balls which are right side of second vertical line indicate with x3, friends. Clear? So x1 contains 3, x2 contains 0, and x3 contains 0. So we are getting this solution, right? So 3, 0, 0. Slowly we are building the concept, friends. Then how will you get 1, 0, 2, friends? So take three identical balls. Your objective is to put 1 in x1, 0 in x2, and 2 in x3, right? So what we will do? Place two vertical lines here, friends. Then number of balls left side of first vertical line indicate with x1. Number of balls between two vertical lines indicate with x2. Number of balls which are right side of second vertical line indicate with x3. See how many balls we are having? Only one ball. So therefore x1 is equals to 1, friends. Okay. Between these two vertical lines we don't have any ball, therefore x2 is equals to 0, right? And x3 is equals to 2. x3 is equal to 2, friends. Okay. Finally let me explain this case like 1, 1, 1, 1. How will you get that case, friends? Okay. Let me explain that case. So place 3 identical ball next to each other. Our objective is to get 1 for x1, 1 for x2, 1 for x3. Therefore place 2 vertical lines here, friends. Okay. So number of balls in x1, 1 ball, number of balls in x2, that equals to 1 ball, number of balls in x3, that equals to 1 ball. I hope you are understanding the concept behind this, right? Okay. So then how you are going to find the solution for this kind of problems? Very simple, friends. Here number of vertical lines always 1 less than the number of variables. Number of vertical lines always 1 less than the number of variables. In this example, friends, look at this here. In this example, how many variables we are having? 3 variables. Therefore number of vertical lines must be 1 less than the number of variables. Therefore I have taken 2 vertical lines. Clear? These 3 identical balls indicates that we are distributing 3 balls here. So total how many places we are having? 1, 2, 3, 4, 5 places. 5 places, friends. Okay. Among these 5 places, we have to choose 2 places to place 2 vertical lines. Correct? Among these 5 places, we have to choose 2 places to place 2 vertical lines. So that if I place 2 vertical lines here, I will get solution 0, 0, 3. If I place 2 vertical lines in this manner, I will get solution 0, 3, 0 like this. Okay. The total number of positions we are having 5 positions. Right? Out of 5 positions, we have to choose 2 positions to place 2 vertical lines in order to generate the solutions. Right? So therefore, how we are going to develop the concept for this one means 3 indicates that identical balls. 3 indicates that identical balls, number of identical balls. Here, number of vertical lines is nothing but number of variables minus 1. Number of variables minus 1. So therefore, if I apply this concept in this problem, so we are having x1 plus x2 plus x3 up to so on xn is equals to r. Xn is equals to r. Means we are distributing r identical balls among n numbered boxes. Now tell me, friends, if you have n variables, how many vertical lines you supposed to place? Let me take in more detail. For example, if I take x1 plus x2 plus x3 plus x4 is equals to 8, friends. So in this case we are having 4 variables. 4 variables means we supposed to take 3 vertical lines. So we can place 8 identical ball next to each other. So we are placing 8 identical ball next to each other. Now since we are having total 4 number of variables, we have to take 3 vertical lines. Suppose if I place 3 vertical lines like this, friends. In this case x1 is having value is equals to 3 because 3 identical balls are there. And x2 is having value equals to 1. And x3 is having value equals to 2, friends. And x4 is having value equal to 2, friends. Clear? So 3 plus 1 plus 2 plus 2, total value equal to 8, friends. Clear? So as a student, what you have to understand, what kind of concept you are going to develop now? Very simple, friends. If there are 8 similar balls, we have to take 8 plus how many vertical lines you have to place? That all depends on number of variables minus 1. Number of variables are here 4 variables. Therefore 4 variables minus 1. These many vertical lines you have to place. Total occupied places here 8 positions for identical balls and 4 minus 1 vertical lines. Out of this, we want to choose 4 minus 1 places to place vertical lines. Okay. Total places are 8 plus 4 minus 1. Out of those places, we have to choose 4 minus 1 places to place vertical line, friends. Now if you could extend this topic for in the general format. Now look at here, friends. x1 plus x2 plus x3 up to so on xn. And how many identical balls we are having? R identical balls. If you place R identical ball next to each other, and how many vertical lines we have to consider? Number of vertical lines always 1 less than the number of variables. So we have to take n minus 1 vertical lines, friends. So therefore we are having n minus 1 vertical lines plus R similar balls. So among these many places, we have to choose n minus 1 places to place vertical lines. Clear? N minus 1 plus R places are there. We have to choose n minus 1 places to place these vertical lines. So that is a solution for the given problem, friends. Okay. That is a solution for the given problem. So by applying this formula in this problem, look at here friends, there are 3 variables, therefore we have to take 2 vertical lines. So first we have to take 2 vertical lines, number of similar balls are 3, we have to take 2 vertical lines. Why it is 2 vertical lines? Because 3 variables are there. So we have to take 2 vertical lines. Total positions are 5 places. Out of 5 places we have to choose 2 places to place 2 vertical lines. Look at here, total 1, 2, 3, 4, 5 places. Out of 5 places I have chosen these 2 places to place 2 vertical lines. Here also 1, 2, 3, 4, 5 places. Out of 5 places I have chosen these 2 places to place 2 vertical lines. Therefore take R number of similar balls, add number of variables minus 1. From those many places you have to choose n minus 1 places to place vertical line friends. So therefore answer to this question is, that is 5C2 friends, 5C2. Okay, so 5C2 value equals to 10. 10 solutions are possible. Here I listed out here 1, 2, 3, 4, 5, 6, 7, 8 solutions I listed out. What are other solutions we can list out here friends? We can take like, let me start with 2. 210 is already completed, right? So total 8 solutions are completed. We want to list out another 2 more solutions friends. Okay, so we start with 0 here, and we start with 1 also, right? And we start with 2, and we want to start with 3. 3 already started here. Then what is other solutions are possible for this one? One, 0, 2, 1, 1, 1, and then so we can take one solution is 0, 1, 2 friends, right? 0, 1, 2 is not available anywhere, right? 0, 1, 2. Another solution we can take it as 0 to 1, right? 0 to 1. Total we are having 10 solutions friends. So this is a way we can find number of non-negative integer solutions for the given problem. Okay, let me see the chart box. I hope you are able to understand the concept, right? Friends, please raise your doubts in the chat box friends. Right, no one is asking doubt. I hope this concept is very clear, right friends? Okay, let me see different types of problems based on this model friends. Okay, so what kind of questions you can expect based on this model? Find number of non-negative integer solutions find number of non-negative integer solutions for the first way of asking question friends, like x1 plus x2 plus x3 equals to 10. It is the first model, okay, which we already covered just now, right? Okay, another way of asking question, find number of non-negative integer solutions for x1 plus x2 plus x3 less than or equal to 10, right? So another way of asking question, find number of non-negative integer solutions x1 plus x2 plus x3 which is less than 10. Okay, fourth one, find number of non-negative integer solutions such that x1 plus x2 plus x3 equal to 10 where we are giving some extra conditions based on the variable friends. Okay, so x1 condition is it must take at most 3, x2 it must take at most 5, and x3 it will take at most 6, maximum 6. Okay, so what is the difference between first model and fourth model? In first model there are no external conditions for x1, x2, x3. The only condition is they are non-negative integer solutions. Whereas in the fourth model, friends, we are having explicit constraints like this. What are the explicit constraints? X1 take at most 3, X2 take at most 5, X3 take at most 6, like this. Clear? And another model which they will ask the question, find number of non-negative integer solutions for 12 less than or equals to x plus y plus z plus w less than or equals to 14. So in first model we have to take equal to symbol, second model less than or equal to case, third case less than 10, fourth case by using some explicit constraints, and fifth case, friends, we are finding solutions between 12 to 14, friends. Okay, 12 to 14. So these are the only 5 different models where they are frequently asking based on the non-negative integer solutions. Sometimes they will ask the questions theoretically also. Theoretically. So what does it mean theoretically? You can expect questions like this, friends. Find number of 3-digit integers in the range 0 to 1000 such that sum of digits of that number is 10. Sum of digits of that number is 10. So sometimes they will ask theoretical questions like this, friends. So this question also we can solve by using that model, friends. Okay, let me go back to the previous ones. It is a first application which I covered in permutation and combination with repetition concept, friends. So this application says that find number of non-negative integer solutions for x1 plus x2 plus x3 and so on xn is equals to r. Clear, friends? Then what is the solution for this one? The solution for this one is we are having r similar balls we are placing next to each other, okay, and we are having n variables which are taking n minus 1 vertical lines. Therefore total number of positions n minus 1 plus r. Out of this position we have to choose n minus 1 places to place vertical lines, friends. This is a solution. Okay, but in the exam they may not ask the same question in this manner, friends. Okay, they may also ask the question like this: how many ways we can distribute or similar balls into n numbered boxes. Clear, friends? This statement is same as previous one, friends. Okay, we are distributing r similar balls among n numbered boxes. Answer remains same. Okay, the same answer we can write here. And another way of asking question is, friends, here number of binary sequences of length n minus 1 zeros or n minus 1 ones, n minus 1 ones, number of binary sequences of length n minus 1 ones, and then, or we can say it is number of binary sequence of length n minus 1 ones, and or we can say it is n minus r, friends. Okay, total we can say n minus r ones, and r zeros, clear, friends? N minus 1, n minus r ones, and r zeros. I will write it in the proper order, friends. So here it is not giving complete meaning. I will write in the proper order. You will get more clarity, because there is space constant here. So I will write in a proper order. So it is the first way of asking question, it is the second way of asking question, friends. So based on these two models, we are having questions like this. Okay, clear? So up to here, do you have any doubts? If you have any doubt, you can ask me, otherwise we will discuss remaining applications also, friends. Let me see the chart box. Kindly post your doubts in the chat box, friends. Yeah, if time permits, I will discuss some graph theory also. Yes. Sure, we will discuss examples now, Rakesh. We will discuss examples. Right, friends. So here the first model already covered, right? x1 plus x2 plus x3 is equal to 10, already covered. What is the solution for this problem, friends? Since we are having 3 variables, therefore we have to take 2 vertical lines, and we are having 10 similar balls, therefore 10 plus 2 C2, friends. Okay, so answer to this question is 12 C2. Next, second question, x1 plus x2 plus x3 less than or equal to 10, means if you sum up all the values, all these values may be equal to 10 or it may be less than 10. So how we are going to answer this kind of model, friends? Okay, let me evaluate this kind of problems now. Second question, x1 plus x2 plus x3 less than or equals to 10. x1 plus x2 plus x3 less than or equal to 10. So in this case, friends, you can take some dummy variable, you can call it as x4. You can take some dummy variable, you can call it as x4. And we are trying to find non-negative integer solution, friends. Since they are non-negative integer solutions, therefore x1 value must be greater than or equal to 0. x2 also greater than or equal to 0. x3 also greater than or equal to 0. Now I am taking one dummy variable, friends, that is x4. So that is x1 plus x2 plus x3 plus x4, this total value equal to 10. Then what is x4, friends, here? What is x4? So that x4 value must be equals to 10 minus of x1 plus x2 plus x3. Suppose if the sum of values in x1 plus x2 and x3 itself 10, then 10 minus 10, x4 value becomes 0. Suppose if the sum of these 3 values equal to 9, then x4 becomes 10 minus 9, that equals to 1. Clear, friends? The sum of these 3 values equal to 5, then 10 minus 5, x4 equal to 5. It is balancing that equation, friends. That's all. Okay. So here also there is a possibility that x4 may be equal to 0. Therefore it is also non-negative integer solutions. Now we want to find number of non-negative integer solutions. We want to find number of non-negative integer solution for this equation. See here, how many similar balls you are distributing? 10 similar balls you are distributing. How many variables we are having? 4 variables. If there are 4 variables, how many vertical lines we have to place? 3 vertical lines. Therefore solution for this one is, so 4 variables, right? 4 variables. Therefore number of vertical lines are 4 minus 1 plus number of similar balls are 10. Out of these many places, we want to choose 4 minus 1 places to place vertical lines. You don't by heart formula, friends. Keep the subject is simple. If there are 4 variables, we have to place 4 minus 1 vertical lines. we are already having 10 similar balls. If you place 4 minus 1 vertical lines, the total number of positions here 4 minus 1 plus 10, that is 13 places. Out of that we have to choose 4 minus 1 places to place vertical lines. Therefore, the answer to this question is 13C3 friends. 13C3. Clear? It is a second model based on this topic. Clear? So let me see the chart box once. Yes, Shakir, that is correct, 13C3. Thank you, Mansi. Yes, Nidhi Sinha, it is correct. Yes, most of you gave correct answer, friends. Thanks for your response. Okay. Let me check next problem, friends. So we have to maintain time limit also. We are having another 10 minutes to complete this topic, friends. Okay. So x1 plus x2 plus x3 less than 10 means if you distribute some balls into these three number boxes, afterwards if you collect them back, the total number of balls are less than 10. Less than 10. So how we are going to solve this kind of problems, friends? Okay. That is third model, which is x1 plus x2 plus x3 less than 10 model, friends. Less than 10. So what we will do, you can write this statement as x1 plus x2 plus x3, you can convert it as less than or equal to 9, friends. Less than 10 means it will take at most 9 only, correct? It will take at most 9. So the moment if you write x1 plus x2 plus x3 less than or equal to 9, it will be converted as second model, friends. It will be converted as second model. Now apply the same procedure here. So what is the procedure I applied in the less than or equal to model? We have to take one extra variable where that variable can be defined like this, right? Let me do the problem quickly, friends. So here each xi, that is x1, x2, x3, all these values are greater than or equal to 0. Okay, now I am introducing another variable now, that is x1 plus x2 plus x3 plus x4, right, equal to 9, equal to 9. Then what is your x4, friends? The value of x4 is 9 minus of x1 plus x2 plus x3. Suppose if the sum of the values of these three variables itself 9, then we can write 9 minus 9, which is 0, friends. If the sum of the values of these three variables equal to 8, we can write 9 minus 8, that equal to 1. So x4 becomes 1. Clear? So there is a possibility that x4 also may be 0. Therefore we can treat it as a non-negative integer solutions. We want to find non-negative integer solution for this problem. Apply shortcut method, friends. Number of variables minus 1. We are having 4 variables, right? Therefore 4 minus 1 plus number of similar balls, that is 9. Out of that we have to choose 4 minus 1, friends. I hope you are not by heart in the formula. You are analyzing the formula and you are doing this problem, right? Okay. You always remember number of variables minus 1, which indicates number of vertical lines, and here 9 indicates number of similar balls. Okay. Total we are having 13 positions. Out of 13 positions we have to choose 3 positions, friends, to place vertical lines. So answer to this question is 13C3. Clear? Let me see the chart box, friends. So most of you give answer is S. Sorry for the mistake. It is not 13C3. So 13 minus 1, 12. So 12C3. Please excuse me, friends. Okay. 12C3. Because 9 plus 4, 13. 13 minus 1, 12. Right? I hope these 3 models are clear, right, friends? Please post your valuable comment in the chat box, friends. Right, friends. Shall we move to next model now? Okay. So we have covered 3 models so far, friends. Okay. Next one, x1 plus x2 plus x3 equal to 10, and each variable is having some explicit constant, friends. Here x1 can take at most 3, x2 can take at most 5, x3 can take at most 6. So it is fourth model, friends. x1 plus x2 plus x3 equals to 10. We are having conditions x1 less than or equal to 3, x2 less than or equals to 5, and x3 less than or equal to 6. We are having some explicit constants like this. Then how we are going to solve this kind of problems, friends? Okay. So what we will do, you can convert these variables like this. Okay. Means at most value of x1 is only 3, friends. At most value of x1 is only 3. So it can take 0 also. Okay. So in such case, let me replace this when x1 is equals to 3 minus y1, friends. 3 minus y1. Okay. Just I am writing x1 equal to 3 minus y1. Then what are the possible values of y1, friends? What are the possible values of y1? Suppose if y1 is equals to 0, if y1 equal to 0, then x1 becomes 3, right? If y1 is equals to 1, x1 becomes 2. If y1 is equals to 2, then x1 equal to 1. 3 minus 2, that equal to 1, friends. Okay. If y1 is equals to 3, then x1 value is 0. I cannot take negative values, friends. I cannot take negative values. Therefore, y1 value starting from 0 up to 3, that is the range of y1, friends. Okay. Range of y1 is starting from 0 ending with 3. Clear, friends? Okay. y1 value lies between 0 to 3. 0 to 3. Clear? So similarly, here you can take x2 is equals to, friends, 5 minus y1, 5 minus y2. Then what is the range of y2? Obviously range of y2 is 0 less than or equal to y2 less than or equals to y2 less than or equal to 5. Okay. Next, x3 is equals to 6 minus y3. The range of y3 is 0 to 6, friends. 0 to 6. Now substitute these values in the place of given equation. Then equation will be converted like this. It is 3 minus y1 plus it is 5 minus y2 and it is 6 minus y3, friends. This total value equals to 10. Clear, friends? Okay. So from this we can write, so 3 plus 5, 8 plus 6, 14. 14 if I bring 10 this side, it becomes 4. Right? 4. So we are having y1 plus y2 plus y3 equal to 4, friends. Right? So 11 plus 3, 14. If I bring this side, that is 14 minus 10, we are having 4. So y1 plus y2 plus y3 equal to 4. Now we had to find non-negative integer solution for this. Non-negative integer solution for this, where y1 is taking at most 3 and y2 is taking 5 and y3 is taking 6. So how many solutions are possible? Total number of variables here, 3 variables, right? So therefore 3 minus 1 plus number of similar balls here, 4. From this we are going to choose 3 minus 1, friends. So which is equals to 7 minus 1, that is 6. So 6C2. So we will get 6C2 solutions, friends. Okay, 6C2 solutions. In these 6C2 solutions, are you going to subtract any other solutions here? Any other solutions? Because we are giving some conditions here. y1 is at most 3 and y2 is 5 and y3 is at most 6. We got 6C2 solutions, but all these 62 solutions are valid or not? We got 6C2 solution. Total number of solutions are 6C2. My question is, are all these 6C2 solutions are valid? Let me explain this. We are having y1 plus y2 plus y3 is equals to 4. How many solutions we can provide this for non-negative integer solutions? Total we can provide 6C2 solutions we can provide. But my question is, are all these 6C2 solutions are valid? Are all these 6C2 solutions are valid? Let me see the chat box, friends. How many of you are answering? Yes. Yes, Agarwal, correct. It is not valid, fine. Then what is the correct answer? What is the correct answer? Yes, Naik, you are right. Yes, thanks for your valuable response. Yes, all the 62 solutions are not valid, friends. The reason is, I can have a solution like this. y1 I can take it is 4 and y2 I can take 0 and y3 I can take 0, friends. So 4 plus 0 which is equivalent to 4. This solution also available in 62. This solution also available in 62 solutions. But what is the explicit condition for y1, friends? The explicit condition for y1 is at most 3 only, at most 3. But you are taking y1 equal to 4, right? Therefore, we have to exclude this combination. We have to exclude that combination, friends. Are you following what I'm trying to say? Actually, if you don't put these conditions, number of solutions are 62. There is no doubt. But the moment if you put explicit condition like this, we are giving restriction on y1 is at most 3. If you say at most 3, there is a possibility that y1 equal to 4 and it is 0, it is 0. This solution also possible. That is one of the solution in 62. Therefore, we have to subtract that case. Right? Is it the only one case or any other case can we subtract? Is it the only one case? Let me see the chat box. Is it the only one case? Please comment in the chat box, friends. Yes, only one case. Only one case. So therefore, number of solution for this problem is 62 minus 1 is the answer, friends. 62 minus 1 is the answer. Clear? Right, friends? But if you want to do this problem, in the examination hall, you no need to write each and every step, friends. You no need to write each and every step. The simple way, what you have to do, total value here 3 plus 5 plus 6. Please look at here, friends. What is the max value of x? x1 3. Max value of x2 5. Max value of x3 6. So the direct step for solving this question is first add all these values, friends. 3 plus 5 8, 8 plus 6 14. So from 14 you have to subtract 10. So 14 minus 10, that is 4. Now we are having 3 variables on the left side, y1 plus y2 plus y3. The right hand side we are having 4. Clear? So direct step y1 plus y2 plus y3 equal to 4, friends. What I'm trying to say, if they provide explicit conditions like this, first sum up these values. From that result you have to subtract 10 and write on the right hand side of equal to operator here. That's you no need to write each and every step in this case. Okay. Clear, friends? Let me see the chart box. Yeah, Arya, you are asking one case minus. Why it is one case minus, Arya? How many total number of solutions are possible, Arya? 62 solutions are possible. In those 62 solutions, I have one solution that is y1 equal to 4 and y2 equal to 0 and y3 equal to 0. That is also one solution is possible, right? So what I am trying to say here, please listen. If you take y1, y2, y3, how many solutions are possible here to satisfy that equation? How many solutions are possible? Means 62 solutions are possible total. Okay. One among those solutions will have some y1 equal to 4, 0, 0, which equal y1 plus y2 plus y3 equals to 4. Correct? But here we are having explicit condition for y1 is at most 3. Therefore, we cannot consider this case. So, by excluding this case, remaining all cases of 62 are possible. Therefore, I am subtracting 1. Is it clear, Arya? Could you please respond back? Yes, Shakir Ali, only one case. Yeah, thank you, Arya. Thank you so much. Any other doubt, friends? Please try to observe what kind of problems we are discussing. Slowly we are increasing the level of complexity level for each and every problem, friends. Okay. Next. Right. So we have completed up to 4 models, friends. We have completed up to 4 models. Then how we are going to this kind of problem, friends? Very simple. You have to find solutions for x plus y plus z plus w is equals to 12, and also find solution for x plus y plus z plus w equal to 13, and also find solution for x plus y plus z plus w equal to 14, friends. Okay, means the solution range from 12 to 14, right? So therefore we have to divide into 3 parts. So first part is x plus y plus z plus w is equals to 12, right? And second part x plus y plus z plus w equal to 13. Third part x plus y plus z plus w equal to 14, friends. Then sum up all these results, you will get the answer. Okay, or else you can do one more way, that is find number of solutions from 0 to 14. From that you can subtract number of solutions from 0 to 12. You will get the same result. Okay, I think no need to evaluate this problem, right? Okay, do you want me to evaluate this problem? Could you please comment in the chat box? Do you want me to evaluate fifth problem, or you can do by yourself? Clear, friends? Right? Okay. So let me discuss next problem. Find number of 3-digit integers in the range 0 to 1000 such that sum of digits of the number is 10. Sum of digits of the number is 10. Okay. Friends, we are having range from 0 to 1000, friends. 0 to 1000. We want to find 3-digit numbers. 3-digit number such that sum of digits of the 3-digit number must be equal to 10. For example, if I take 163, it is a 3-digit number. It is a 3-digit number which lies in the range 0 to 1000, and sum of the digits must be equal to 10, friends. Okay. So what is sum of the digits here? 1 plus 6 plus 3 equals to 10. Clear, friends? Similarly, I can take 3-digit number like something like 208, which is in this range 208, and sum of the digits must be equals to 10, friends. So like that, how many 3-digit numbers are there? Sum of the digits must be equal to 10. Clear? Can anyone answer this question? Just post your comment in the chat box. Could you please post in the chat box? Yes, Somani, it is correct, Somani. Yeah, Mahit, you answered is 12C2. 12C2. Can you evaluate and tell me what is 12C2 value? Please evaluate and tell me what is 12C2 value. Is it 66? Right. So we don't want to waste our valuable time in this class, friends, because the time is very precious for us. I'll directly explain this concept, friends. Okay. So what I will do, I'll take x1 and x2 and then x3, because we are going to construct 3-digit number. 3-digit number contains ones place, tens place, hundred place, right? So assume that it is units place. Units place. Okay. It is tens place. It is hundred place. Clear, friends? For example, if you take 163, friends, 163, what I'm assuming that, suppose if I consider units place, so x1 is in units place. If I consider is tens place, x2 is in tens place. If I consider is 100 place, x3 is in 1. Clear, friends? So therefore x1 plus x2 plus x3 must be equal to 3 plus 6 plus 1, that equal to 10. Clear? So I am taking x1, x2, x3, where x1 indicates units place. I'll write that point here, friends. It is units place. Okay. It is tens place. It is 100 place, friends. Okay. 100 place. Clear? If I sum of these 3 digits, we'll get the solution is 10. If you sum up these 3 digits, we'll get solution is 10. Now again, this problem is converted into find the number of non-negative integer solutions. Correct? Apply the formula, friends. How many variables we are having? 3 variables. Therefore vertical lines are 3 minus 1. Every time I am mapping this concept to vertical lines, please recall the basic. So the title of this course is concept series. We are developing concept, friends. We are developing concept. We are not by-hearting any formula. Clear? So in the beginning I explained what is the concept behind this. Based on that we are doing different kind of problems. I hope this session is very useful for you, friends. Okay. So total number of variables we are having 3. Therefore 3 minus 1 vertical lines are there. How many similar balls we are having? 10. From this we have to choose 3 minus 1, friends. Okay. Which in turn itself 12C2. Right. Therefore 12C2 numbers are there. What is 12C2, friends, value? What is 12C2 value? I think 12C2 value is 66, right? 12C2 value is 66. Means there are 66 3-digit numbers are there. There are 66 3-digit numbers are there, from the range 0 to 1000 such that sum of the digits of those numbers must be equal to 10. Are you following what I'm trying to say? Here I found 163, I found 208. Like that, how many 3-digit numbers are there? 66 3-digit numbers are there. Sum of the digit must be equal to 10. But is it final solution, friends? Could you please comment in the chat box? Is it the final solution, or can we subtract something else? Is it final solution? So what I'm trying to ask you here, please listen. We are having variables like x1 and x2 and then x3. If a sum of these values, this total value must be equals to 10. How many ways I can do it? Means total we can do 66 ways. We can do 66 ways, friends. But my question is it final solution? Let me write one of the way. One of the way is I can take something like 2 is here and 6 is here and 2 is here. Correct? That is one of the way. Let me take here 3 and then 5 and then 2, which is 352. That is also equal to 10. Like that, how many solutions we are having, friends? Like that, how many solutions we are having? 66 solutions are there. But my question is, are these 66 solutions are valid solutions, or can we subtract more? Okay, let me see the chat box. Yes. Shaurya Agrawal, you have written 12C2 minus 11. That is 55. No. $55, no. Then what is final solution? Yes, Mahit, your answer is correct, Mahit. 63 is correct. Yes, friends. There are 3 situations where we have to subtract from here, friends. Look at here. Suppose, for example, x1, if I write it as 10, friends, x2 is 0 and then x3 is 0. This total value it is giving the result equal to 10. Correct? But what is x1, friends, here? x1, x2, x3, they are digits. Digit always starting from 0 and ending with 9 only, right? Digit always starting with 0 and ending with 9. But I am getting digit which is 2 numbers, 2 digits, which is not possible, right? Therefore, I cannot take x1 equal to 10 and x2 equal to 0 and x3 equal to 0. That case is not valid. Similarly, I can place 0 here and x2 value is 10 and x3 value is 0. So this case is also not valid, friends. Okay. Another case is 0 plus 10. This case also not valid. So why they are not valid? The reason is you have taken x1 is unit digit, x2 is tens digit, x3 is 100 digit. Digit is nothing but it contains only number between 0 to 9. We cannot take 10 as a digit. 10 is a number, it is not a digit. Is it clear or not? But this solution also satisfied, right? 10 0 0, 0 10 0, 0 0 10. These 3 combinations also satisfied. Therefore, final solution is not 66, friends. Out of 66, we have to subtract 3 cases. We'll get answer is 63, friends. Okay, we'll get answer is 63. Yes, Mahit, it is correct. Yeah, Tiwari, it is correct. Shaikar Ali, it is correct. Friends, if you could understand this topic, please type something else in the chat box. Have you understood or not? If it is clear, please type clear in the chat box, friends, so that we will move to the next topic. If it is clear, please type clear in the chat box, friends. Yes, very much clear. Thank you, Anand Tiwari. Thank you. So we started with a simple problem, x1 plus x2 plus x3 equal to 10. Slowly we are increasing the complexity level by taking less than or equal to model, by taking less than model, by taking constants on the variables, right? And also by looking at theoretical problems based on the topic. I hope you are having confidence in the topic, that is applications of combination with repetitions. Is it clear, friends? Okay. Right, crystal clear. Thank you so much. Thank you so much for your valuable comment, friends. Let me go back to our timetable slot. Let me see what we planned in the beginning. Yes. So 4 to 4:45 applications of combination with repetition, which we successfully completed. Of course, it is taking extra 10 minutes time. No problem, friends. No problem. Don't worry about time. Now we are going to discuss second topic is formation of recurrence relation, friends. It is also most important topic, friends. GATE examination point of view, formation of recurrence relation is most important topic. Clear? Let me discuss the topic, friends. Our second topic is formation of recurrence relations. Friends, before starting this formation of recurrence relation, let me explain what way they will ask the questions, friends. Okay. There are three ways of asking questions in this topic. The first way is they will provide one theoretical statement and they will ask you to form the recurrence relation. We'll discuss problems now. Okay. They will provide one theoretical statement. They will ask you to find the recurrence relation for the given problem. For example, in one of the GATE paper, they ask what is the recurrence equation for towers of an eye problem. What is the recurrence equation for towers of an eye problem? Okay. Then what is the recurrence equation for finding binary sequence such that no two consecutive zeros are possible? Clear? These are theoretical problems, friends. They are theoretical problems. After forming recurrence relation, you have to solve recurrence relation, friends. Okay. The second step is solving recurrence relations. Solving a recurrence relation, friends. It is the most important topic, friends. If you ask me to give rating for this, I can give 5-star rating, friends. Okay, because every question paper contain at least one question based on this topic, friends. Okay, so you can give 5-star rating for this one, friends. Okay, solving recurrence relations. So how many methods we are having solving recurrence relations? The first method is very easy method, that is substitution method, friends. Substitution method. Okay, substitution method. And the second method is called master theorem. Master theorem. And third one, solving by using a recursion tree. A recursion tree approach. And fourth one, method of characteristic roots. Method of characteristic roots. And fifth one, method of undetermined quotients. Method of undetermined coefficients. Clear, friends? Friends, if you have time, you can take 100 pages notebook, separate notebook, and write recurrence relations. Okay, in this order, friends. Substitution method, master theorem, recursion tree, method of characteristic roots, method of undetermined quotient, like this. Okay, so definitely you can get minimum 4 to 5 marks based on this topic. Why I'm talking about 4 to 5 marks? Because this topic is not restricted to only discrete mathematics. The same topic will arise in algorithm subject, same topic will arise in discrete mathematics, same topic will arise in programming language also. So therefore, friends, this master theorem, substitution method, master theorem, recursion tree approach, you have to collect information from algorithm subject, friends. Algorithm subject. Sir will teach in detail. Okay, you have to collect information about these three topics in algorithm subject. And method of characteristics, method of undetermined quotient, which is completely related to our discrete mathematics, friends. Okay, discrete mathematics. But in our regular class, I almost spent more than 12 hours only for solving these equations. You please read my notes number of times. Okay, because it is not the right time to discuss these models. If I start discussing this model, complete time will be wasted only for these two models, friends. Okay, so please read my notes. In the notes, I clearly explain how to solve problem by using method of characteristic roots, how to solve problem by using method of undetermined quotients. Clear, friends? Here what I will do, I will discuss only formation of recurrence relations, how to form the recurrence relations. Clear, friends? Okay, let me see the chart box, friends. Yeah, set theory I will try, friends. Raghavendra, I will try. Groups also I will try, Raghavendra. Okay. Right, friends. Now look at formation of recurrence relations. So what is a form of recurrence relation, friends? So it is not the right time to discuss a definition of recurrence relation also. Expressing present term in terms of previous terms is called recurrence relation, friends. For example, if you see arithmetic progression like a plus d, a plus 2d, a plus 3d, and so on, a plus n minus 1 into d. It is general arithmetic progression, friends. Here we can call it as a first term t1, it is second term t2, it is third term t3, t4, and so on. It is nth term, friend, tn. If you observe the relation among all the terms, we can write t2 as t1 plus d, t1 plus d, correct? T1 is equal to a and a plus d, which is giving t2, friends. Similarly, if you take t3, we can write it as t2 plus d, friends, t2 plus d. So by continuing this process, friends, if you take tn, we can express it as tn minus 1 plus d. So the present term expressed in terms of previous term, this is one of the example for recurrence relation, friends. Okay, it is one of the example for recurrence relations. Let me take another example for recurrence relation. So suppose if you take geometric progression ar square, ar cube, and so on like this, ar to the power of n minus 1, which is known as nth term, friends. Okay, it is first term t1, it is second term t2, it is t3, t4, and so on, it is tn. So obviously here if you take t2, let me take t1, friends, t2, t3, t4, and so on, tn. So I can express t2 as t1 multiplied by r. t2 we can express ar into small correction, friends, t1 means a into r, right? Similarly, if you take t3, we can express it as t2 into r. What is t2? That is ar. t2 is ar into r, ar square. Clear, friends? By continuing this process, we can write tn is equals to tn minus 1 into r. We are expressing present term in terms of previous term. So that is the reason it is also called form of the recurrence relation for the given geometric progression, friends. Okay, we have seen arithmetic progression, we have seen geometric progression, right? Okay, let me take another example where if you have the series like 0, 1, 2, and then 3, 5, and then 8, 13, and so on like this. If you consider this sequence, friends, okay, let me take here it is 1 also. So we can call it as a t1, it is t2, it is t3, it is t4, let it be t5, t6, t7, t8 like this. If you observe this sequence, the present term can be obtained by sum of its immediate two previous terms. The present term can be obtained by taking sum of its immediate two previous terms, friends. So it means that t8 can be expressed as t7 plus t6. Okay. Similarly, t7 can be expressed as t6 plus t5. By continuing this process, friends, tn can be expressed as tn minus 1 plus tn minus 2. So here we are expressing present term in terms of its immediate two previous terms. It is also called a recurrence form of the Fibonacci series. Okay, these are basic concept, friends. Okay, I don't want to waste your time by discussing these basics. My intention is to discuss problems in recurrence relation, formation of recurrence relation. But before discussing formation of recurrence relation, you must have idea about what is recurrence relation, right? That's why I introduce this concept. Clear the formation of clear the example of recurrence relation now. Right. Let me check formation of the recurrence relation problems now. What type of questions you can expect in formation of recurrence relations? 1 minute, friends. Meanwhile, ask me doubts if you have any doubt. Right, friends, look at this problem. First problem, the recurrence relation for the maximum number of pieces of a pizza made by n straight cuts. The recurrence relation for the maximum number of pieces of a pizza made by n straight cuts. Could you please comment your answer in the chat box, friends? We'll discuss. Let me see the chat box. Thank you, Kashif Jaidi. Thank you. Thanks for your compliment. Yeah, could you please post answer for this question, friends? Kindly post your answer in the chat box. Right, friends, so I'm defining f of n. Let me define f of n as f of n is equals to maximum number of pieces of pizza, maximum number of pieces of pizza made by n straight cuts. Made by n straight cuts. Clear, friends? Friends, while forming recurrence relation, the definition of f of n is most important, friends, here. Okay, if you don't define it properly, the complete meaning of this problem will be changed. Okay, observe how I define f of n. F of n indicates maximum number of pieces of pizza. Maximum number of pieces of pizza made by n straight cuts. I'm not asking total number of pieces. I'm asking maximum number of pieces of pizza. Therefore, here underlying point is, it is most important point, friends. Okay, because our objective is to find maximum. So maximum number of pieces of pizza made by n straight cuts. Let me take different cases, friends, here. So let me take n value and f of n value, friends. F of n value. What is f of n indicates? F of n does not indicate total number of pieces of pizza. F of n indicates maximum number of pieces of pizza, friends. Okay, maximum number of pieces of pizza. Okay. Suppose let me take n value and f of n value, friends. Okay. Suppose if I perform n is equals to 1. N is equal to 1 means we are performing only one straight cut, friends. Only one straight cut. If we perform only one straight cut, how many pieces we can form by using one straight cut? Assume it is pizza. We are performing one straight cut, friends. As a result of performing one straight cut, number of pieces here 2 pieces. Therefore, f of 1 is equals to 2, friends. Don't read it as f of 1 simply. You always read like this: maximum number of pieces of pizza made by one straight cut equals to 2. There are only 2 pieces maximum, friends. Okay, fine. Let me increase here. Let me take n is equals to 2, friends. Let me take n is equal to 2. So earlier we are having 2 pieces now. Okay. Now I'm taking second straight cut. N is equal to means we are performing 2 straight cut, friends. 2 straight cuts. Okay. Let me take 2 straight cuts. Okay. Earlier we had 1 straight cut. Now I'm taking second straight cut. Now total number of pieces equals to 4. Are you looking about total number of pieces? Are you looking about maximum number of pieces? We are looking about maximum number of pieces. Obviously maximum number of pieces also 4 here. Okay. So therefore f of 2 is equals to 4, friends. 4. The logic is here, friends. Just observe this statement once again. Just observe once again, friends. Suppose if I remove this one, earlier we are having 2 pieces. Earlier we are having 2 pieces. Okay. So therefore, let me take this one as, earlier we had 2 pieces, right? Earlier we had 2 pieces. That's why I'm writing 2 pieces as it is. But as a result of performing second straight cut, count the number, second straight cut. As a result of performing second straight cut, 2 more pieces added. 2 more pieces added. Earlier we are having 2 pieces. Now 2 more pieces added. Therefore, 2 more pieces added. Clear? This 2 indicates that straight cut number. What is straight cut number here? Second straight cut. Second straight cut. Okay. If we perform second straight cut, 2 more pieces added. Okay. Let me take third straight cut, friends. Okay. So we had 2 straight cuts already. Now I'm going to perform third straight cut. Observe here. Suppose if I perform third straight cut like this. I hope everybody, is it visible for everyone, friends? Okay. Right. Okay. So suppose if I perform third straight cut. Now count how many pieces of pizza are there. How many pieces of pizza? I'll write this one here so that we will get more clarity. It is a third straight cut, friends. How many pieces of pizza are there? It is first straight cut. It is second straight cut. Now I'm performing third straight cut like this. How many pieces of pizza are there? 1, 2, 3, 4, 5, 6 pieces. 6 pieces. Tell me, friends, are you looking about total number of pieces of pizza? Or are you looking about maximum number of pieces of pizza? Obviously maximum number of pieces of pizza. Here I am getting only 6 pieces. I am getting only 6 pieces. Let me try another way. So initially we are having 2 straight cut, friends. Now I am drawing third straight cut such a way that number of pieces must be maximum. Okay. So that third straight cut, what I am going to do, that third straight cut I am drawing in this way, friends. In this way. Means the third straight cut must intersect previously drawn 2 straight cuts at 2 distinct points. So that number of pieces will be increased. Observe how many pieces are there. 1, 2, 3, 4, 5, 6, 7. 7 pieces this time. Earlier we had only 6 pieces. This time we are having 7 pieces. 7 pieces. Okay. Let me explain one more time this point, friends. Now see, friends, up to here 2 straight cuts are there. Up to here 2 straight cuts are there. For 2 straight cuts, how many pieces we had? 4 pieces. See here, for 2 straight cuts we are having 4 pieces. Therefore, maximum number of pieces made by 3 straight cuts is equals to, earlier we are having 4, right? Earlier we are having 4 pieces. Now as a result of performing third straight cut, observe here, I am performing third straight cut. It is a problem with the smart board, friends. Like this, third straight cut. As a result of performing third straight cut, how many extra pieces added, friends? Earlier we had 4 pieces. Earlier we had 4 pieces. Now how many extra pieces added? See, 1, 2, 3, 4, 5, 6, 7 pieces. It means earlier we had 4 pieces, extra 3 more pieces added. That is plus 3. Plus 3. Now observe logic here, friends. Second straight cut, adding 2 pieces, for the previously computed number of pieces. Okay. Third straight cut adding 3 pieces. Now if we could extend this topic, now if you take n is equals to, it is not the correct way of representing this one. Like this. Okay. So third straight cut is adding 3 pieces for the previously computed n minus 1 straight cuts. So if I continue this process, friends, if it is fourth straight cut, then we have to take f of 4 is equals to previously computed value. What is previously computed value? 4 plus 3, 7. 7 plus straight cut number. Straight cut number is 4, friends. Means 11 pieces. 11 pieces will be there if you perform 4 straight cuts. Okay. In general, friends, this 7 indicates that f of 3 plus 4. F of 3 plus 4. Right. In this case, this 4 indicates that f of 2. 4 indicates that f of 2, and this 2 indicates that f of 1. So what I'm trying to explain here, please observe this one. So maximum number of pieces of pizza made by second straight cut is equals to maximum number of pieces of pizza made by first straight cut plus extra how many pieces adding? 2. Maximum number of pieces of pizza made by third straight cut is equals to maximum number of pieces of pizza made by second straight cut plus extra 3 pieces. Third straight cut means you had to add 3 pieces. Similarly, maximum number of pieces of pizza made by n straight cuts is equals to maximum number of pieces of pizza made by n minus 1 straight cuts plus extra n pieces, friends. Okay. So therefore the correct answer for this question is option A is the correct answer, friends. Okay. So this is the way we have to develop the problem, friends. Okay. Let me see the chart box. Right, friends. Nice. I hope this concept is clear, right, friends? Friends, the same question if they want to ask in algorithm subject point of view, they may ask the question like the recurrence relation of the maximum number of pieces of pizza made by n straight cut is given like this, then what is the time complexity for computing this? What is the time complexity for computing this? In that case, you have to solve this recurrence equation by using methods which they are going to discuss in algorithm. Clear, friends? Okay. So we know how to solve this kind of recurrence equation, right? T of n is equals to T of n minus 1 plus n. Clear? Right. Let me discuss next problem, friends. Right. Look at this problem. The recurrence relation for the maximum number of nodes in a binary tree of depth d. Before starting this problem, could you please respond in the chat box? Is it clear the previous problem? Could you please type if it is clear? Could you please type clear in the chat box, friends? Yes, Shekhar Ali, it is correct. N square, order of n square is correct. Previous problem, time compressed order of n square is correct. Yeah. So most of your typing it is clear. Thanks for your response, friends. Right. Thank you, Vinati. Thank you. Fine. Next question, friends. See here, this question is related to data structure also. Means subject which we are discussing discrete mathematics, but we are able to form a recurrence relation with the concepts of other subjects also, friends. Because in the examination you cannot identify the question belongs to which subject, right? Okay. They may combine 2 or 3 subjects like this. Okay. So the recurrence relation for the maximum number of nodes in a binary tree of depth d. To answer this type of question, you must have idea about binary tree properties, friends. Okay. Suppose let me take here a binary tree. So I am taking a full binary tree, friends. The reason why I am taking full binary tree, because here they are talking about maximum number of nodes are possible only if the tree is full binary tree, friends. Maximum number of nodes are possible if the tree is only full binary tree. That's why I'm taking full binary tree here, friends. Okay. Generally, the root node is at depth d is equal to 0, friends. Let me take depth value in terms of d. So root node is at depth d, that equal to 0, friends. Okay. Next, these are the nodes at depth 1, right? And these are the nodes at depth 2, and these are the nodes at depth 3, friends. Clear? Then how many number of nodes are there at each depth? number of nodes at a depth d. See how many number of nodes are there at depth d, friends. Here we are having only one node, so that one node we can express it as 2 to the power of 0, friends. Why we are expressing 2 to the power of 0, we'll discuss little later. Friends. Okay. At a depth d equal to 1, how many number of nodes we are having? At depth d equal to 1, we are having 2 nodes, friends. 2 we can express it as 2 power 1. Okay. Similarly, at depth 2, we are having 4 nodes, we can express it as 2 power 2. At a depth 3, we are having 8 nodes, we can express it as 2 power 3. In general, friends, at a depth d, how many nodes we will have? At a depth 0, we are having 2 power 0. At a depth d equal to 3, we are having 2 power 3. In general, at a depth d, how many nodes we are having? 2 power d nodes are there. Okay. So at depth d, we have 2 power d nodes. Clear, friends? We have 2 power d nodes. These are basic concepts you have to understand from the data structures. Okay. Then we can come back to the discrete mathematics. We can construct recurrence relation, friends. Okay. Now look at the options here. They are defining in terms of n of d. You can define n of d as, let n of d is equals to maximum number of nodes of a binary tree which has a depth d. Clear, friends? They are talking about maximum. For example, in this case, what is the depth? So depth of this tree is equal to 3, friends. Then how many max number of nodes are possible? That is 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3. These many known. This is the total number of nodes, friends. But our objective is to forming recurrence relation, right? Okay. The simple logic, friends. See, n of d is equals to, if you want to find maximum number of nodes of depth d, then you have to count up to maximum number of nodes of depth d minus 1, correct? You have to count maximum number of nodes up to depth d minus 1. Maximum number of nodes up to depth d minus 1 denoted by n of d minus 1. Afterwards, at depth d, how many nodes we are having? 2 power d nodes. So 2 power d nodes. The present term is expressed in terms of previous term, therefore it is a valid recurrence relation, friends. Okay. Observe the logic here. I want to find maximum number of nodes in a binary tree whose depth is equal to 3. In that case, I can find maximum number of nodes of a binary tree up to depth d equal to 2, and extra I can add 2 power d nodes. Therefore, it is 2 power d nodes. So therefore, the correct answer for this question is option A is the correct answer. Sorry for the mistake. The correct answer is n of d is equals to n of d minus 1 plus 2 power d. Okay. Please comment in the chat box, friends. Yes. One time in the GATE paper they asked recurrence relation of the tower of an eye also. Please read data structures class notes, we will understand recurrence relation of tower of an eye. Shall we move to next problem, friends? Okay. So these problems are very important and interesting problems, friends. Okay. Just read the problem. The recurrence relation for the number of n-digit quaternary sequences that have an even number of zeros. Can you try and comment your answer in the chat box? The recurrence relation for the number of n-digit quaternary sequences. Please post your answer in the chat box, friends. Yeah, Unnati, actually you have to develop concept from data structures itself, like how many nodes are there at each level, like that. Okay. Could you please post answer in Mansi Somani, option C. Viral videos, option C. The recurrence relation for the number of n-digit quaternary sequences that have even number of zeros. So what is the concept behind this, friends? Okay, it's the most important area, so I'll take time for explaining this concept, friends. Okay, only one student posted answer for this question. Yeah, option C. Thank you, viral videos, thank you. Friends, this is the one area where a student often get confusion, so therefore I'll take time for explain this concept, friends. Okay, let me go back to notepad and I'll come back to this question, friends. Okay. So slowly we'll develop the concept behind this problem, friends. Generally they will ask questions like this. The number of binary sequences of length n the number of binary sequence of length n which contain even number of zeros. Even number of zeros. It is one way of asking question, friends. Okay. And the second way of asking question, the number of ternary sequences of length n, the number of ternary sequence of length n which contain even number of zeros. Which contain even number of zeros. And the third way of asking question, the number of quaternary sequences of length n which contain even number of zeros. Which contain even number of zeros. Friends, if you could understand these three questions clearly, you can easily solve any question based on this topic, friends. Okay, you can easily solve any question based on this topic. So therefore please focus here. So first one is they are talking about binary. So obviously here binary sequence is nothing but it is forming with either 0 or 1. Ternary sequence is nothing but it is forming with either 0 or 1 or 2. Quaternary sequence is forming with 0, 1 or 2 or 3, friends. Clear? So first we will develop the concept. What is the concept behind this kind of problems, friends? Okay. Friends, suppose I am considering a binary sequence of length n like x1, x2, x3 and so on xn. It is a sequence of length n. Suppose if that sequence is binary sequence, if the sequence is binary sequence, friends, then every variable having two possibilities, either 0 or 1, 0 or 1, like this, okay? 0 or 1, 0 or 1 and so on, 0 or 1. Clear? Then how many such sequences are possible? If each element is having two possibilities, right, and if you have n such variables, then total number of sequences here 2 power n, friends, okay? Total number of sequences 2 power n. 2 power n sequences are possible, okay? I hope you understood why it is 2 power n. Let me take only 1 minute time. One sequence we can take it is 0 0 0 up to so on 0, friends, okay? Another sequence 0 0 0 up to so on 1. By continuing this process we'll have 1 1 1 and so on 1. So the total number of sequences which we have 2 power n sequences. Similarly, if it is a quaternary sequence, or if it is a ternary sequence, then the total number of sequences becomes 3 power n if it is ternary sequence. Clear? If it is a quaternary sequence, each element is having 4 possibilities, will have 4 power n. Clear? Remember these basic concepts. If it is a binary sequence, total number of sequences are 2 power n, ternary means 3 power n and quaternary means 4 power n, okay? Number of binary sequences, number of ternary sequences and number of quaternary sequences. So these basic concepts are useful for solving that question, friends, right? I hope up to here it is very clear, right, friends? Up to here it is very clear. Then we are going to solve each and every problem now. First we will focus on number of quaternary sequences of length n which contain even number of zeros, I am defining let an is equals to number of quaternary sequences of length n which contain even number of zeros, Just we define like this, friends, because definition of n is most important here, friends. Definition of n is most important, okay? Now let me consider a quaternary sequence of length n. Assume that it is a quaternary sequence of length n, friends, okay? Assume it is a quaternary sequence of length n. Then first we will focus on first digit, friends, okay? First digit, it may be means first position, it may be 0 or 1 or 2 or 3, because a quaternary sequence is forming with either 0 or 1 or 2 or 3. Clear? So what I will do, I will focus only on first digit, friend, first bit. I will focus only on first bit. What are the possibility for filling that first bit, friends? So we want to develop the concept behind this. That's the reason I'm writing every step, friends, okay? You please have a patience to understand this question. What are the possibility to place first bit, friends? Okay, first one. So I am having possibility like 0, 1, 2, 3. I'm expecting even number of zeros. Friends, suppose if I place first bit is 1, I'm expecting even number of zeros. Now if first bit is 1, that bit completely wasted, we are not getting even number of zeros. Agree or not? If the first bit is 1, I'm expecting even number of zeros here. Okay, that bit completely wasted here. Then what is the length of remaining sequence? The remaining sequence length is n minus 1. From those from that n minus 1 sequence length, I'm expecting even number of zeros. Okay, if we expect even number of zeros of sequence length n, we are defining it as an. Now if the first bit is 1, that first bit completely wasted because we are not having even number of zeros here. From the rest of the n minus 1 bits, I am expecting even number of zeros. Therefore, how to write in the form of notation? We can write it as an minus 1, friends. An minus 1. Just read the statement. An indicates that number of quaternary sequences of length n which contain even number of zeros. If I write here an minus 1, then number of quaternary sequence of length n minus 1, correct? Number of quaternary sequence of length n minus 1 which contain even number of zeros. I hope it is very clear. If I keep first bit is 1, that bit completely wasted because our requirement is to find even number of zeros. Therefore, from the remaining sequence of length n minus 1, I am expecting even number of zeros. That's the reason I can take it is an minus 1, friends. Okay. Right? Change this one also. Clear, friends? This is the case if you take first bit is 1. Suppose if you take first bit with 2, friends, because we are having 4 possibilities here. I started with 1. If I take first bit is 1, from the remaining sequence of length n minus 1, I am expecting even number of zeros. That's why it is an minus 1, friends. Okay, that's why it is an minus 1. Suppose if I take first bit with 2, then this first bit completely wasted because I am expecting even number of zeros. From the remaining sequence of length n minus 1, I am expecting even number of zeros. So again it is an minus 1, friends. Okay. Suppose if I fill first bit with 3, then this bit completely wasted because I am expecting even number of zeros. So from the remaining sequence of length n minus 1, I am expecting even number of zeros. I hope up to this point it is clear. Any doubt up to here? No. Now definitely you have to focus more in this case while I am substituting first bit is 0. Is it clear, friends? I am going to substitute first bit is 0. Please focus more here. Okay. Suppose if the first bit is 0, friends. This case is clear, second case is clear, third case is clear, right? Okay. If I substitute 0, since I am expecting even number of zeros, I already having 1 0. From the rest of the sequence I am expecting odd number of zeros. Getting logic or not? Repeating once again. My objective is to get even number of zeros, friends. I already filled 0 at the first place. In order to get even number of zeros, since you are already having 1 0, remaining bits must have odd number of zeros. Therefore, here I am expecting odd number of zeros. Okay, I am expecting odd number of zeros, friends. Odd number of zeros of length n minus 1. Okay, it means that here we are expecting quaternary sequence of length n minus 1 with odd number of zeros, friends. With odd number of zeros. This is crucial part, friends. Okay, if you could understand how to generate odd number of zeros here, you will get clear about all kind of problems. Okay, then how we are getting odd number of zeros, friends? I will get odd number of zeros. Very simple, friends. Please observe. We are defining total what is sequence of this length, friend? Sequence of this length is n minus 1. If it is n minus 1 sequence length, then how many ternary sequences are possible? How many ternary sequences are possible? Okay. If the sequence length is n, then number of ternary sequences is equals to 4 to the power of n. In the beginning I already explained, if the sequence length is n, then the number of ternary sequences are, sorry for the mistake, it is not ternary, quaternary. Please excuse me friends. Number of quaternary sequences, please excuse me, sorry for the mistake. So number of quaternary sequence must be equals to 4 power n. Clear friends? So here I define an as, please look at here friends. In the beginning how did I define an? An denote that number of quaternary sequence of length n which contain even number of zeros. An defined as number of quaternary sequence of length n which contain even number of zeros. Even number of zeros. Okay. So what I will do friends in this case, if the sequence length is n, then the number of quaternary sequence is equals to 4 power n. Okay. Number of quaternary sequences of length n which contain odd number of zeros, is equals to, tell me friends how we are going to write. Total how many sequences are possible? 4 power n. From the 4 power n, if I could subtract even number of zero sequences, but even number of zero sequence I define it as an. Have you remembered? From the total sequence, if I could subtract even number of zero sequences, then remaining I will get odd number of zero sequence only. It is only crucial part for understand this problem friends. Okay, most of the students are getting problem for finding odd number of zero sequences. Okay, very simple friends, from the total number of sequences you have to subtract even number of zero sequences, we will get odd number of zero sequence. Now apply this basic concept for the given problem friends. It is a concept which I am going to use in this problem. Clear? Come back to our problem. What is problem friends? Here I am expecting quaternary sequence of length n minus 1 which contain with odd number of zeros. Quaternary sequence of length n minus 1 with odd number of zeros. Tell me friends, total how many sequences are possible? Number of sequences depends on the length of the sequence. What is the length of the sequence here? N minus 1. Therefore total number of sequences are 4 to the power of n minus 1. From those sequences we have to subtract even number of zero sequences. How many even number of zero sequences are possible? an minus 1 friends. Clear? I hope it is very clear. You have to comment in the chat box friends, then only I can understand. Okay, now this problem I can do in how many ways? This problem I can do in first way, or in second way, or in third way, or in fourth way. Now you can apply sum rule friends. Therefore by using sum rule, number of quaternary sequences, please observe friends, number of quaternary sequence of length n, an is equals to number of quaternary sequence of length n with even number of zeros is equals to, either it could be first case an minus 1, or it could be second case an minus 1, or it could be third case an minus 1, or it could be this case 4 to the power of n minus 1 minus of an minus 1. Please look at here friends. First case an minus 1, it is an minus 1, it is third case, it is fourth case. By simplifying this we will get it is an is equals to 1, 2, 3, here these two get cancelled, so 2 times of an minus 1 plus 4 to the power of n minus 1. That's all friends. Okay, if you could understand this concept clearly, you can easily solve any problem based on this model. 2 into an minus 1 plus 4 to the power of n minus 1. Now apply same logic for binary sequence, for ternary sequence as well. Okay, we will discuss that also. We will discuss that problem also friends. Okay, number of binary sequence of length n which contains even number of zeros, number of binary ternary sequence of length n which contains even number of zeros. Okay friends, if you really understood this concept, please comment in the chat box friends, so that I can continue remaining problems. Let me see the chat box. . Clear, right? Yes, the generating function concept is also important. Please refer my class notes. Yes, Vanity, we will discuss second problem, we will get more clear. Okay. Right, friends? Let me discuss ternary sequence in the same fashion, friends. Okay. We are going to discuss number of ternary sequence of length n which contains even number of zeros. Let me define that point. Let an is equals to number of ternary sequences of length n which contain even number of zeros, friends. Which contains even number of zeros. Now focus on first bit, friends. Ternary sequence means we are having three possibilities, right? First bit may be filled with 1 or 2 or 0. Okay. Right, friends. Suppose if I fill first bit with 1, if I fill first bit with 1, I am expecting even number of zeros and first bit occupied with 1. Therefore, this bit completely wasted, friends. Okay. From the remaining sequence of length n minus 1, I am expecting even number of zeros. If the sequence length is n, even number of zeros can be defined as an. If the sequence length is n minus 1, even number of zero sequence can be defined as an minus 1. Clear? Similarly, if the first bit, here first bit is 1, suppose if the first bit is 2, friends, because ternary sequence is filled with 0, 1, 2, 0, 1, 2. So first bit is 1 completed, the first bit is with 2, but I am expecting even number of zeros, and this bit is completely wasted because its number is 2. Okay. From the remaining sequence of length n minus 1, I am expecting even number of zeros, that is a n minus 1, friends. Okay. So first bit filled with 1 case completed, first bit filled with 2 case completed, first bit may be filled with 0 also. If it is 0, from the remaining sequence of length n minus 1, I am expecting odd number of zeros because I already having 1 0, right? So therefore from the remaining sequence of length n minus 1, I am expecting odd number of zeros. Here I am expecting number of ternary sequences of length n minus 1 with odd number of zeros. Now you can easily guess how many ways we can find. Very simple, friends. Find total number of sequence of length n minus 1. Total number of sequence of length n minus 1 is 3 power n minus 1 because it is a ternary sequence. If it is a ternary sequence, total number of sequence of length n minus 1 is 3 power n. From that we have to subtract even number of zeros sequences. Even number of zero sequence we define it as an minus 1. Correct? If the length of the sequence is n minus 1, even number of zeros, how many? Even number of zero sequence, how many possible? An minus 1. So therefore the task will be completed either first way or second way or third way, friends. Therefore it can be written as an is equals to an minus 1 plus an minus 1 plus 3 to the power of n minus 1 minus of an minus 1. Clear? So by simplifying it, an is equals to an minus 1 plus 3 to the power of n minus 1. Apply same procedure for binary sequence of length n which contains even number of zeros. We'll get more clarity, friends. Okay. Can you comment in the chat box, friends? Unnati, is it clear this time? I'm running a little bit fast. Very much clear. Thank you. Thank you so much. Thank you, Unnati. Is it clear, friends? So this is the way we can form the recurrence relations. I hope this concept is very clear for everybody. You can practice questions like this. So formation of recurrence relation is completed, friends. Okay. The next topic which we are going to discuss here, types of relations. Types of relations, and also we'll discuss different kind of problems based on types of relation, friends. Okay. Any doubts, friends? Could you please type in the chat box? Right. So what kind of question you can expect in types of relations, friends? Okay. So we are having different types of relations, starting with reflexive, right, ending with partial order relation, friends. Okay. So then what kind of questions you can expect from those topics? Okay. Actually relation is nothing but here subset of given Cartesian product, right, friends? What is the meaning of relation here? Suppose if you take any set, non-empty set A, let A is a non-empty set, let A is a non-empty set, then any subset of A cross A is called relation, friends. Okay. Any subset of A cross A is called relation from A to A. Clear, friends? Any subset of A cross A is called relation from A to A. So the reason why I am discussing definition here, because without having proper definition we cannot answer number of reflex relations, number of symmetric relation, number of anti-symmetric relation, like that, friends. Okay. So any subset of A cross A is called relation, right? Okay. Now you tell me, friends, suppose if cardinality of A is equals to n, then how many elements are there in the cardinality of A cross A? Obviously cardinality of A cross A contains n square elements, friends. Okay. Then how many relations are possible from A to A? Number of relations from A to A. How many relations are possible from A to A? I don't know how many relations are possible from A to A, but I know the definition of relation, that is subset of A cross A is called relation from A to A. Subset of A cross A is called relation from A to A. Therefore number of relation from A to A is nothing but number of subsets number of subsets of A cross A. Clear? Number of subsets of A cross A. How to find number of subsets of A cross A? Which is nothing but cardinality of power set of A cross A. Correct? Cardinality of power set of A cross A. If A contains n elements, A cross A contains n square elements, then its power set must contain 2 to the power of n square elements. We have one formula based on power set. Please refer class notes, you can get clear idea. So which is equals to cardinality of power set of A cross A means which is nothing but 2 to the power of n square. Because the moment A cross A contains n square elements, number of elements in power set must be 2 power n square. So therefore total number of relations from A to A is equal to 2 power n square relations. Now from those relations we want to discuss how many relations are reflexive, how many relations are symmetric, how many relations are anti-symmetric, and so on. We will continue our discussion, friends. Okay, is it clear up to here, these basic concepts? Let me see the chart box. Right, friends. Okay, observe how to generate number of relations which are reflexive, symmetric, antisymmetric, asymmetric, transitive, and so on like this. Okay, suppose let me consider A is equals to 1, 2, 3, 4 and so on n. The set A contains n elements. Now A cross A can be defined like this. A cross A is equals to 1 comma 1, 2 comma 2 by continuing this process up to n comma n here, and remaining we can write 1 2, 2 1, 1 3, 3 1 up to so on 1 comma n comma 1. Just I am writing A cross A value, friends. Okay, it is called A cross A, right, friends? Okay, then how we are going to discuss reflex relations? Reflex relation says that all diagonal elements compulsory present, friends. Okay, all diagonal elements compulsory present. So every element is having two possibility here, either it may be present or absent, So when it comes to reflex relation, every diagonal element compulsory present, friends. Every diagonal element compulsory present. Okay, so if you want to show in the form of matrix representation, so we are having 1 2 3 up to so on n, 1 2 3 up to so on n, friends. So the first element 1 comma 1, 1 comma 2, 1 comma 3 and so on 1 comma n. Similarly we are having 2 1, 2 2, 2 3 up to so on 2 n. By continuing the procedure, here we are having n1, n2, n3 up to so on n comma n, friends. So if you observe this matrix, in this matrix, friends, there are exactly n diagonal elements. Number of diagonal elements are exactly n, friends. Okay, number of diagonal elements. Exactly we are having n elements, friends. Okay, and number of non-diagonal elements. Number of non-diagonal elements. This matrix contains exactly n square elements. From those n square elements, if you subtract diagonal elements, we will get non-diagonal elements, which is equals to n square minus n. Clear, friends? N square minus n. These n square minus n elements will be divided into two equal parts. Half of the elements are below the diagonal, half of the elements are above the diagonal. Clear, friends? So here you have to understand n square minus n elements are there which are non-diagonal elements. These non-diagonal elements are divided into two equal parts. Half of the elements, that is n square minus n by 2 elements below the diagonal, n square minus n by 2 elements which are above the diagonal elements. Okay, those are called symmetric pairs. Those are called symmetric pairs. For example, if you take 1 2 and here 2 1, these two are called symmetric pairs. Okay, similarly if you take 1 3 here, we will get 3 1 here. So those two are called symmetric pairs. So if I consider like that, okay, how many diagonal elements we are having? N diagonal elements, friends. We have n diagonal elements. Clear? And if you see symmetric pairs, 1 2 2 1 is symmetric pair, 1 3 3 1 is symmetric pair, and so on. 1 n n 1 is symmetric pair. The total number of symmetric pairs here, we are having n square minus n by 2 symmetric pairs. Why n square minus n by 2? Because total number of non-diagonal elements are n square minus n. These n square minus n, half of the elements are below the main diagonal, and half of the elements are above the main diagonal. Therefore, total number of symmetric pairs are n square minus n by 2 symmetric pairs. N square minus n by 2 non-diagonal symmetric pairs. Non-diagonal symmetric pairs. Okay. If you could understand these two important concepts here, you can easily find how many number of reflex relations, how many number of symmetric relations, on like this. Okay. So first we'll discuss number of reflex relation, friends. Number of reflexive relations. So by assuming cardinality of A is equals to n, and we have A cross A which is equal to 1 1 2 2 and so on, n n 1 2 2 1 1 3 3 1 and so on, 1 n, then n 1. Clear, friends? How to find number of reflex relations? Number of reflexive relations. The most important point in reflex relation is all diagonal elements are compulsory present, friends. All diagonal elements compulsory present. Therefore, how many ways we can keep all diagonal elements are present? Only one way, right? We can keep all diagonal elements are present only one way. So it is present, it is present, it is present, like this. There is only one way to make them present. And remaining non-diagonal elements, they may be present or absent. They may be present or absent. Therefore, each non-diagonal element having two possibilities: absent or present, absent or present, absent or present, like this. Absent or present. Clear? So how many ways we can keep all diagonal elements are present? Only one way. So therefore we can write 1 followed by, because we are applying product rule between these two, because the whole task will be completed if you complete these two subtasks one after another. The whole task is finding number of reflex relations. We can find number of reflex relation by completing these two subtasks one after another. Okay. Now see, friends, here how many non-diagonal elements we are having? N square minus n non-diagonal elements. How many non-diagonal elements are there? N square minus n non-diagonal elements. But each non-diagonal element having two possibilities, right? Each non-diagonal element is having two possibilities. Therefore, total number of possibilities are 2 to the power of n square minus n. Have you remembered in the beginning I explained, if each variable is having two possibilities, if there are n variables, we will have 2 power n. If each variable is having three possibilities, if we have n variables, we will have 3 power n possibilities. Like that, if each element is having two possibilities, if you have n square minus n elements, then 2 power n square minus n. Remember, friends, when you are developing formula, you always develop formula into two segments. One is diagonal part, another one is non-diagonal part. If this explanation is clear, you can easily solve remaining problems, finding number of irreflex relations, number of symmetric relations, and so on like this. Let me see the chat box, friends. Up to here it is clear. Could you please type clear if it is clear, friends? If you have any doubt, please ask me. Clear, right, friends? Okay. Then how to find number of irreflex relations? So number of irreflex relation, friends. What is the key point for irreflex relation, friends? In irreflex relation, all diagonals compulsory absent, friends. All diagonals compulsory absent. How many ways we can keep all diagonals are absent? There is only one way, right? Like we can keep it is absent, it is absent, it is also absent. We can keep all diagonals are absent only one way, friends. Therefore, I am writing only one way to keep all diagonals are absent. Followed by I am developing this formula by dividing it into two segments. One is diagonal segment, another one is non-diagonal segment. Fine. In irreflex relation, friends, what about non-diagonal elements? Non-diagonal elements may be present or may be absent. So there are two possibilities for non-diagonal element. Therefore, 2 to the power of n square minus n. Clear, friends? 2 to the power of n square minus n. Formula remains same for both reflex and irreflexive, but the way how we are reading this formula is important. Formula remains same for both reflex and reflexive, but the way how we are reading this formula is important. Let me read it once again, friends. I can keep all diagonal elements are present only one way, and each non-diagonal element is having two possibilities. There are n square minus n non-diagonal elements are there. Therefore, 2 to the power of n square minus n. Here, I can keep all diagonal elements are absent only one way. Only one way, by placing all our zeros, right? And a non-diagonal element having two possibilities, therefore 2 to the power of n square minus n. Clear? Student must understand that number of diagonal elements are n, number of non-diagonal elements are n square minus n, number of symmetric pairs, non-diagonal symmetric pairs are n square minus n by 2 symmetric pairs. If you could understand these 3 points, you can easily solve problem, friends. Okay, right. Afterwards, number of symmetric relation, friends. Friends, actually this class aim is students have already attended my class, whether it is live class or offline class. Students have already attended my class, and it is not the first time they are listening this class. Okay, it is kind of repetition, friends. That's the reason I am running a little bit fast to cover more number of concepts. But if you are really attending first time, maybe you feel difficulty for understanding concept. But in the regular class, I taught very slowly each and every concept. Okay, so I hope you can understand why I'm talking this one, because I'm running a little bit fast today to cover more number of concepts. Okay, my assumption is students have already attended either my offline class or online class, and it is not the first time they are watching this video. Okay, they already watched my live videos earlier also. So it is the way, means it is another chance to get revision for them, friends. Okay, clear? Next, number of symmetric relations. Number of symmetric relations, friends. What is the basic key point for finding symmetric relations here? Friends, first focus on diagonal elements. In symmetric relation, diagonal elements are having two possibilities. Either it may be present or it may be absent. Either it may be present or absent. So therefore there are n diagonal elements are there, each diagonal element having two possibilities, like absent or present, and so on, absent or present. Clear? Every diagonal element having two possibilities. Therefore first diagonal part followed by non-diagonal part. Every time I am writing formula into two segments. Diagonal part says that there are two possibilities, either it may be present or absent. So first you can write possibilities. How many such variables are there in the diagonal? N variables, therefore 2 power n. Clear, friends? Okay. Entire discrete mathematics depends on only the sequence, friends. If the variable is having two possibilities, if there are n variables, 2 power n possibilities are there. If the variable having three possibilities, there are n variables or 3 power n possibilities are there. Okay. So like that, there are n diagonal elements are there, each diagonal element having two possibilities, therefore 2 power n possibilities. What about non-diagonal element, friends? It is interesting, listen. What about non-diagonal elements? What about non-diagonal elements, friends? In symmetric relation, friends, in symmetric relation, suppose 1 2 is presented, then definitely 2 1 must be present in the relation. Then only we can call it a symmetric relation. So for that pair 1 2 2 1, we are having two possibilities. If 1 2 is present, 2 1 also present. Okay, 1 2 is present, 2 1 also present. Or else if 1 2 is absent, 2 1 is also absent. Clear? Therefore this symmetric pair is having two possibilities. What are the two possibilities? Either both are present or both are absent. Similarly, these two are having same possibility. If 1 3 present, 3 1 is present. 1 3 absent, 3 1 is absent. If 1 n present, n 1 is also present. If 1 n is absent, n 1 is also absent. It means that each symmetric pair having two possibilities. Each symmetric pair is having two possibilities. Therefore first I am writing possibility. Possibility is 2. But how many such symmetric pairs are there? In the beginning I already explained. How many such symmetric pairs are there? N square minus n by 2 symmetric pairs are there. Therefore 2 to the power of n square minus n by 2. Clear, friends? Let me recap within 1 minute. In reflexive relation, all diagonal elements are present only one way. Non-diagonal elements are having two possibilities. There are n square minus n non-diagonal elements, therefore 2 power n square minus n. Why we are using multiplication symbol here? Because we are applying product rule. In a reflexive relation, all diagonal elements are compulsory absent by placing 0 0 0 only one way, and the non-diagonal elements are having two possibilities. There are n square minus n non-diagonal elements, therefore 2 power n square minus n. But when it comes to symmetric matrix, symmetric relation, in symmetric relation all diagonal elements having two possibilities, either it may be absent or present. Therefore I have written 2 in the base. But how many such diagonal elements are there? N, therefore 2 power n. Clear? When it comes to non-diagonal elements, non-diagonal we have to frame symmetric pairs, 1 2 2 1, 1 3 3 1, 1 n n 1 like this. Each symmetric pair is having two possibilities, either both are present or both are absent. Like that, how many symmetric pairs we are having? N square minus n by 2 symmetric pairs. Therefore 2 to the power of n square minus n by 2, friends. I hope it is clear. Up to here it is very clear. Friends, if it is clear, in order to get motivation for me to teach remaining concepts, please type in the chat box CLEAR, clear, so that I will continue remaining also. Okay. Thank you, Anati. Thank you. Thank you, Shakir Ali. Thank you, Nidhi Sinha, Rakesh Raj, Vikas. Thanks for your response. Thank you, Nayak. Right, friends. So up to here this point is clear, right, friends? Okay, let me continue for remaining relations also. After symmetric relation, when you are talking about antisymmetric relation, friends, antisymmetric relations. Again divide the formula into two segments. First one is diagonal, another one is non-diagonal. Okay, first we are going to give preference for diagonal, friends. Afterwards we will discuss non-diagonal. Now you tell me, friends, in antisymmetric relation, what about diagonal elements? Very simple, friends. In antisymmetric relation, diagonal elements may be present or may be absent. Means there are two possibilities are there in antisymmetric relation, right? Therefore, two possibilities. But how many such diagonal elements are there? N. Therefore, 2 power n. Clear? Then what about non-diagonal symmetric pairs? It is quite interesting, friends. In antisymmetric relation, non-diagonal symmetry pairs having three possibilities. What are the three possibilities? Let me explain. When do you say it is antisymmetric, friends? We can say it is antisymmetric. Suppose 1 2 is present, compulsory 2 1 is absent. Then only we can say it is antisymmetric. 1 2 is presented, then compulsory 2 1 is absent. Or else if 1 2 is absent, then 2 1 may be present. Okay, 2 1 may be present. Or else if 1 2 is absent, 2 1 is also absent. These are three possibilities, friends. Okay, 1 2 present and 2 1 is absent, or 1 2 present maybe 2 1 is 1 2 absent maybe 2 1 is present, or both of them may be absent. Clear? If I can continue like this, here also if 1 3 present, then 3 1 compulsory absent. If it is absent, it compulsory present, or both of them are absent. Similarly, if it is present, it is absent. If it is absent, it is present, or both of them are absent. Means each non-diagonal symmetric pair is having three possibilities this time. Earlier we are having two possibilities, but this time we are having three possibilities. Therefore, first we can write three possibilities. How many such symmetric pairs we are having? N square minus n by 2 symmetric pairs. Friends, in the midnight also you have to remember these points. In a matrix of order n square or n by n matrix, how many diagonal elements are there? N. How many non-diagonal elements are there? N square minus n. How many symmetric pairs are there? N square minus n by 2 symmetric pairs. Please remember these points. Okay. So 3 to the power of n square minus n by 2, friends. Okay. These many antisymmetric relations are possible. I hope it is very clear for everyone, right? Normal students, means average students, they are going to read the formula like this. Number of antisymmetric relations are 2 power n into 3 to the power of n square minus n by 2. But ranker, they never read as it is what they are appearing in the notes. They will always try to construct the sentence. Number of antisymmetric relations. There are n diagonal elements. Each diagonal element is having two possibilities. Therefore, 2 power n possibilities. Right? When it comes to non-diagonal symmetric pairs, there are n square minus n by 2 non-diagonal symmetric pair is there. And every symmetric pair is having three possibilities. What are the three possibilities? Either 1 0 or 0 1 or 0 0. Each symmetric pair is having three possibility. There are n square minus n by 2 symmetric pairs, therefore 3 power n square minus n by 2. They will try to construct sentence. They don't read as it is which it is appearing in the notes, friends. Okay. If you develop concept like this, you never forget the subject, friends. Okay. Next. After antisymmetric relation, friends, what we have to discuss? Number of asymmetric relations. Number of asymmetric relations. Tell me, friends, what is a golden rule that I explained in the asymmetric relation? For every relation I explained one golden rule in the class, right? What is a golden rule? Friends, whenever they are talking about asymmetric relation, all diagonal elements compulsory absent in asymmetric relation. It is a golden rule you have to remember. Okay. How many ways we can keep all diagonal elements are absent? We can keep all diagonal elements are absent only one way. Therefore, we can take one. It is a golden rule. In asymmetric relation, all diagonal elements compulsory absent. I can keep all diagonal elements are compulsory absent only one way. That is one way. Afterwards, when it comes to non-diagonal elements, friends, non-diagonal elements having again three possibilities like as antisymmetric. What are three possibilities? If 1 2 is present in asymmetric relation, compulsory 2 1 is absent. If it is 0, it is 1, or both of them are absent. Therefore, that is 3 to the power of n square minus n by 2. Clear, friends? Now obviously we'll get one doubt. Sir, it is 1 into 3 to the power of n square minus n by 2. It is 2 power n into 3 to the power of n square minus n by 2. Means here diagonal elements compulsory absent. That case already covered here. So can I say every asymmetric relation is antisymmetric? Comment in the chat box, friends. Can I say every asymmetric relation is antisymmetric? Let me see the chat box. Please tell me, friends, is every asymmetric relation is antisymmetric? Is every asymmetric relation antisymmetric? Yes, but converse cannot be true. Yes, boss, you are right. Yes, friends. Okay, because obviously it is subset of this one, right? It is subset of this one. So every asymmetric relation compulsory antisymmetric relation. Every asymmetric relation is compulsory antisymmetric relation. Okay. You may have another doubt, friends. In irreflexive relation, all diagonal elements are absent only one way. In asymmetric relation also, all diagonal elements are absent. Then can I say every asymmetric relation is irreflexive? Can I say every asymmetric relation is irreflexive? Yes, friends. Every asymmetric relation is irreflexive only. Clear? Every asymmetric relation is irreflexive only. Because all diagonal elements are absent, right? Okay, fine. So after asymmetric relation, so what do we have to discuss? Reflexive is completed, irreflexive completed, symmetric, antisymmetric, and asymmetric is completed. Friends, here we don't have any formula for finding transitive relation. Therefore, I am not discussing formula for transitive relation, friends. Okay. But we have one formula for finding number of equivalence relation, friends. Number of equivalence relations. Number of equivalence relation on a set n must be equals to Bell number Bn, friends. Okay, Bell number Bn. So that is one formula which I already provided in the notes. You please refer that notes, friends. Okay, number of equivalence relations for a set n is equal to Bn, where Bn is Bell number, friends. Here Bn is Bell number. You refer what are the Bell number elements like. You take table like n value and then Bn value. Substitute n is equal to 1, n is equal to 2, n is equal to 3, up to you can remember at least 5 elements, friends. Okay, at least you can remember it up to 5 elements. Okay, and see what are the Bell number values which I already provided in the class notes. Okay, just read them. So actually 2 times they asked in the GATE paper for finding number of equivalence relation. One time they provided 3 elements, one time they provided 4 elements. 4 elements are there means 15 equivalence relations are possible. B4 is 15. Okay, please refer my class notes in order to understand what is Bn. Bn stands for Bell number, friends. Okay, so first stage of relations concept is over. Like in first stage I explained how many number of relations are possible: reflexive, irreflexive, symmetric, antisymmetric, right, and equivalence relations. Now we are moving to second stage, friends. Okay, up to this part is clear, everybody? Yes, diagonal element 1 1 2 2 nn is antisymmetric, Agarwal. It is correct. It is antisymmetric, Agarwal. It is correct. Right. So before moving to the next stage, let me explain what kind of questions they will ask based on relations, friends. Okay, let me go back to the PPT so that we'll get more clarity. So GATE examination point of view, we can expect questions like this, friends. Okay, these are previous paper GATE questions. You can expect questions like this. Can you answer first question, friends? Just answer first question and post your comment in the chat box. Kindly post your answer in the chat box. Yeah, please give me response, friends. What is the answer for first one? Because you answered is B, option B. Okay, friends, let me explain how do you answer this kind of questions in the GATE paper. Please listen, friends. Here x comma y relation present, so we can make it as 1. Sorry for the mistake. What are the elements are related here? X is related to y, friends, right? So x is related to y, and x is related to z, and z is related to x, z is related to y. Remaining elements are not related, therefore we can show with the value 0, friends. Value 0. Now you please forget about these options. You please kindly forget about these options. Let me explain how we are going to answer these kind of questions in the exam hall, friends. Okay. First, represent relation in the form of matrix. First, represent relation in the form of matrix. After representing, first verify all diagonals are present or not. Verify all diagonals are present or not. Suppose if all diagonal elements are present, friends, then we can say it is reflexive. If all diagonal elements are present, we can say it is reflexive. Clear? Please observe, friends. How we are going to verify reflexive relation? Verify all diagonal elements are present or not. Present means 1, 1, 1 like this. Then we can say it is reflexive. But all diagonal elements are not present here, therefore it is not reflexive. Okay? So it is not reflexive. Fine. Next, how we are going to verify irreflexive? How we are going to verify irreflexive? So what you will do, friends, you focus only on diagonal elements. If all diagonal elements are zeros like this, all diagonal elements are zeros, then obviously it is irreflexive. Here all diagonal elements are zeros, friends. All diagonal elements are zeros. Because only xy related and xz related, zx related and zy related. So all diagonal elements are zeros in this case. Therefore it is reflexive. Sorry, it is irreflexive. It is not reflexive, but it is irreflexive. But it is irreflexive. Okay. Then afterwards, how do you verify symmetric, friends? How do you verify symmetric? Very simple, friends. The given matrix you can call it as M. Given matrix you can call it as M. And find M transpose, friends. M transpose. If M transpose is equals to M, then we can say that relation or that matrix is symmetric matrix. In linear algebra, you might have studied that if the transpose of the given matrix is equals to original matrix, then that matrix is called symmetric matrix. The same concept I am explaining here. Find the transpose of this matrix. If the transpose is equal to the or same as the original matrix, then we can say relation is symmetric. Let me check this one. First row 0, 1, 1, friends. First column 0, 0, 1. Obviously first row not same as first column. Okay, symmetric matrix is nothing but first row same as first column, second row same as second column, third row same as third column. So in this case, M transpose equals to M, we can say it is symmetric. But here M transpose equal to M is not possible, therefore it is not symmetric. Okay, it is not symmetric. Clear friends, it is not symmetric. Fine. How do you verify antisymmetric, friends? How do you verify antisymmetric? While verify antisymmetric, it don't focus on diagonal friends. Don't focus on diagonal, because by default diagonal are antisymmetric. Correct? By default diagonals are antisymmetric. That's why you never focus on diagonals. Only you have to focus on non-diagonal symmetric pairs. If any one of the non-diagonal symmetric pair exists, then it is not antisymmetric. Okay. Focus here. You please forget about diagonals. Now xy is 1, but yx is 0. Means symmetric pair is not existing here. Fine. Next, xz is 1, zx is 1. See here, symmetric pair is existing, right? If at least one symmetric pair is existing, it is not antisymmetric. Okay. If at least one symmetric pair is existing, what is the meaning of symmetric pair here? Xz symmetric pair is zx. So xz present, zx present. Hence, it is not a antisymmetric, friends. Okay. It is not a antisymmetric. It is not a antisymmetric. Tell me, is it asymmetric relation or not? See, once it is not a antisymmetric, friends. Okay. You are saying it is not antisymmetric. Obviously, it is not asymmetric, because here antisymmetric relation xz is present, zx is present. Obviously, asymmetric also zx xz present here. Therefore, it is not asymmetric. Okay, not antisymmetric. It implies that it is not asymmetric also, because of xz and zx. So this is a way you can to identify this one. But a transitive property you can verify manually. But in the exam it is not required, because if you could remember this point, key points, you can eliminate 3 out of 4 options, then 4th option is the correct answer. Elimination option is also very important strategy, friends. Okay, it is not required to find every time right answer. Sometimes you try to eliminate 3 options, friends. Okay, after elimination of 3 options, rest of the option is the correct answer. Okay, while doing relations problems, especially while we are verifying transitive property, it don't verify transitive property in the beginning itself. First, what we will do, we will try to eliminate options, friends. Okay, after elimination of options, definitely remaining option is the correct answer. So there is no necessity of verification of transitive property in most of the problems. Okay, so what is the answer for this one? R is not antisymmetric, R is not symmetric, R is not antisymmetric. So obviously it is option D is correct answer. Okay, let me see the chart box, friends. Right. What about next question, friends? What is the possible number of reflexive relations on a set of with 5 elements? It is straightforward problem, friends. Okay. The formula for reflexive relations 1 into 2 to the power of n square minus n. So 1 into 2 to the power of n square means 5 square 25 minus 5, that is 20. So answer this question is 2 power 20, friends. Right, option C is correct. Right, friends? Next question. Friends, here it is one way of asking question on relations. They will define one relation, they will ask whether it is symmetric or not. If you observe very closely this problem, they define relation R on the set. They define relation R on the set. Sometimes they will define relation R on ordered pairs. Sometimes they define relation R on set of sets. Let me discuss remaining, you will get more clarity. Look at here, friends. Let R be the relation on the set of positive integers such that A related to B if and only if A and B are distinct and have a common divisor other than 1. They are distinct, have a common divisors other than 1. Then which of the following statement is true? Can you answer this question, friends? What is your answer for this question, friends? Can you try post your answer in the chat box, friends? Right, friends. Observe how can you answer these kind of questions. They clearly mention that A related to B if and only if A not equal to B and they have common divisors other than 1. It means that GCD of A comma B not equal to 1, friends. We have another common divisor also. So it is a notation for GCD of two numbers. Clear? So when you are talking about reflexive relation, reflexive relation says that every element must be related to itself. So we have to show that A related to A, friends. A related to A. We have to show that A related to A for every element A belongs to given set. Okay. Positive integers they define, that will be Z plus. We want to put that A related to A. According to this condition, A related to A if and only if A not equals to A and GCD of A comma A not equals to 1. Is it possible, friends? Whenever A related to B, these two conditions must and should hold. Suppose if I take let A related to A, friends, we are assuming that let A related to A. Then if let A related to A, then obviously A not equal to A, GCD of A comma A not equal to 1, which is not possible, friends. Okay, which is not possible. Therefore, A does not related to A. Means it is not satisfying reflexive property. Clear? So if it is not satisfying reflexive property, we can eliminate this option and we can eliminate this option also. Right, friends? Okay. Now we are having only two possibilities: transitive but not reflexive and not symmetric, symmetric but not reflexive and not transitive. So let me check symmetric property, friends. Symmetric property says that let A related to B. Let A related to B. So whenever A related to B, we supposed to prove that B related to A, friends. Okay, that means we supposed to prove that B related to A. So by assuming A related to B, we supposed to prove that B related to A. But whenever A related to B, it must satisfy the condition if and only if A not equals to B and GCD of A comma B not equals to 1. Means they have other common divisor also. Okay, friends, this statement we can also write B not equal to A not equal to B same as B not equal to A and GCD of B comma A not equals to 1. It means that B related to A, right? B related to A. Okay, so therefore whenever A related to B, we can prove that B related to A for all A comma B belongs to given set. Hence it is symmetric. Hence it is symmetric. Okay, so if it is symmetric, here they mention not symmetric, right, friends? Not symmetric. So eliminate this option also. It is one of the previous paper GATE question. After elimination of three options, obviously answer D is the correct answer, friends. Okay, you no need to take time for verification of transitive. So in first example which we covered earlier, they asked relation on a set. Okay, here they provided condition, explicit condition, A related to B if and only if A and B are distinct and have a common divisor other than 1. It is second model, friends. Okay, And the third model, look at here, just look at this problem. They define relation on collection of sets. They define relation on collection of sets. First problem, they define relation on set. Second problem, they explicitly define A related to B by using condition A and B are distinct and GCD of A comma B must be equal to 1. Clear? But this time they are defining relation on collection of sets. Please comment your answer in the chat box. Please comment your answer in chat box, friends. Yeah, Unnati, you are asking about reflexive property, previous problem, right? Unnati, previous problem, you listen Unnati once again. Reflexive property means we want to prove that A related to A. We want to prove that A related to A. For all A belongs to given set. Here set is set of positive integers. Please listen Unnati. If you supposed to prove this one, we can say it is satisfying reflexive property. But according to definition, they mention that A related to B if and only if A and B are distinct and A and B are having common divisors other than 1. Clear? So suppose if I assume that it is satisfying reflexive property. Suppose if I assume that it is satisfying reflexive property. So that's the reason I am taking let A related to A. So the moment if I say it is satisfying reflexive property, whenever A related to A, by using given condition, we can say A not equals to A and GCD of A comma A not equals to 1 according definition. Now you tell me, is it possible that A not equal to A? No, right? Therefore our assumption is wrong. Okay, so which is not possible here, which is not possible, so our assumption is wrong. Our assumption is wrong. What is our assumption? Our assumption is A related to A is our assumption, which is wrong. That is the reason A does not relate to A. I hope it is very clear Unnati now, right? Friends, please comment your answer in the chat box. Thank you Unnati, thank you. Yeah, Chaudhary, you are talking about answer is B, right? Symmetric but not transitive. Fine. So most of you post answer is B. Try friends, try. So this time they defined relation on collection of sets, friends. Okay, please look at here. They defined relation on collection of sets defined by A related to B. Suppose I am taking collection of sets, let it be capital M. Capital M. Friends, sets are always denoted by capital letters. Sets are always denoted by capital letters. Therefore, I am taking collection of sets like A, B, C, D, E. These are called sets and so on like this. Now M is the collection of sets. Now on that set M we are going to define relation. How we are going to define relation? See, two sets are related with each other if and only if their intersection is pi. Okay, it means that for all A comma B belongs to given set capital M, A related to B if and only if A intersection B is equals to pi. Clear friends? If A intersection B equal to pi, then only they are related. Now let me explain reflex relation first. How we are going to prove reflex relation? First we assume that it is satisfying reflex relation. Okay, let set A related to set A for all A belongs to given set capital M. we have to assume that it is satisfying reflexive property, right? With that assumption, if we get anything contradiction, then we can say our assumption is wrong. But whenever A related to A, according to this condition, that is if and only if A intersection A is equals to pi. Tell me friends, A intersection A equal to pi for every A in the set, is it possible? It is not only with respect to capital A, okay, so but also for every element they are talking. Therefore if and only if A intersection A equal to pi for all A belongs to M, is it possible friends? Maybe one or two sets are possible, but for every set how it is possible friends? No, right? Okay, A intersection A equal to pi for all A belongs to M, which is not possible, which is not possible. So if it is not possible, obviously our assumption is wrong. Therefore our assumption wrong. Hence we can say A does not related to A friends. A does not relate to A. So if it is not reflexive, we can eliminate option A. We can eliminate option A. Equivalence relation is nothing but it must satisfy three properties: reflexive, symmetric, right, transitive. Since it is not reflexive, so it is not equivalence relation also. It is not equivalence relation also. Okay. Now competition between B and D. They are talking about symmetric and transitive. Let me check symmetric property friends. Okay. Symmetric property. Assume that A related to B friends. A related to B. By assuming A related to B, we supposed to prove that B related to A. But whenever A related to B, A intersection B must be equal to pi. So A related to B if and only if A intersection B must be equal to pi. Means intersection of these two sets equal to pi friends. Now you tell me friends, if intersection of A and B is pi, obviously intersection of B and A also pi. B and A also pi. Hence we can say that B related to A. B related to A. So it is symmetric friends. Whenever A related to B, we prove that B related to A. So it is symmetric. So but here they mentioned it is not symmetric. So we can ignore this option. So answer is symmetric and not transitive. I am leaving it to you for transitive verification. But examination point of it is not required to go up to transitive friends. Okay, it is not required to go up to transitive. Let me see the chart box. Right, someone is asking explain about transitive, right? Okay, you can take some counter example simply. What is transitive for this? Someone is showing interest about transitive relation. We'll discuss transitive also. So what we have to assume that let A related to B, okay, and B related to C, and finally we want to put that A related to C friends. We want to put that A related to C. So whenever A related to B, obviously it says that A intersection B equal to pi. Whenever B related to C, it says that B intersection C is equals to pi. By using these two, if we can prove that A intersection C is equal to pi, clear? So by using these two, if we can show that A intersection C equal to pi, we can say that A related to C. Okay, but you think friends, if the intersection of A and B is pi and intersection of B and C is pi, can you ensure that intersection of A and C is equal to pi? Is it compulsory? Take two sets friends. Suppose A is equals to 1, 2 and B is equals to 3, 4. Clear friends? Now the intersection of A and B is pi. Intersection of A and B is pi. Okay, and if you take C, which is 2, 6, clearly intersection of B and C is also pi. Correct? Pi. But if you take A intersection C is not pi friends. A intersection is not equal to pi. So here A related to B, B related to C, but A does not related to C. Okay. Hence it is not transitive, friends. Hence it is not transitive. Is it clear, Unnati? Yes. Regarding tomorrow's subject, they will announce in the Telegram link. Right. So this is the way you can expect questions in relations, friends. Now I am going to discuss, of course we have to continue because there are many formulas also there here. You practice them. So I am going to discuss few more concepts in first order logic, friends, so that I feel that I am covering many concepts, right? Okay. Up to this part is clear, everybody? If it is clear, type clear in the chat box. We will move to the first order logic, some important shortcut methods which is really useful to you. If it is clear, please type clear in the chat box, friends. Yes, Rakesh Raj, QRC course is my class is not available because last year recorded by some other faculty, so they are continuing the same only. Anyways, all topics we covered in the class, right? Friends, now I am going to discuss most important tricks for solving first order logic questions and propositional logic questions, friends. It is clear, everybody, right, friends? Right. So I am discussing some new important model in first order logic and propositional logic, friends. Please focus now. So in propositional logic, friends, we are having connectivities. We are having connectivities in order to combine two atomic propositions. Those connectivities are negation, conjunction, disjunction, implication, by implication. Okay, negation, conjunction, disjunction, implication, by implication. It is the order of evaluation, friends. Okay, it is the order of evaluation. Is the order of precedency. It is order of precedency, friends. Okay. For example, if I have negation T or P implies Q and or by implication of yes. Suppose we are having a compound proposition like this. What is the order of evaluation in this case, friends? So first you have to give preference to negation. First you have to give preference to negation. Here let me explain one more also, friends. Okay, let me take S and L. Let me take S and L. Okay. So first to whom I have to give the preference? That is negation. Therefore order of evaluation is looking like this. It is the first step. Okay, I can write step 1, first step. After negation, to whom you have to give the preference? Conjunction. But we are having two conjunctions right here, Q and R, S and L. To whom I have to give the preference? Friends, here you always evaluate connectivity operators from right to left. From right to left, friends. Okay. So therefore you have to give preference to S and L, which is having second priority. Clear? After this we can evaluate Q and R, which is third one. So after conjunction, next precedence is goes to disjunction. So we are having disjunction here, therefore we can evaluate these two. So which is having fourth precedence, friends, in this case. Okay. After disjunction we are having implication. So implication between these two, therefore we can evaluate this part, friends, which is fifth step. Okay. So afterwards we are having conditional, therefore between these two we can use conditional. It is sixth step. It is order of evaluation of connectivity operators. Do you have any questions in this order of evaluation, friends? In the first step I had to explain first order logic. Yes, conjunction is having right precedency. That is the reason I am taking S and L second time. By default, everything we are evaluating from right only. By default, everything we are evaluating right only. For example, if you have statement, second example, friends, if you have P implies Q implies R, P implies Q implies R. What is order of evaluation means? First you have to evaluate right one, that is Q implies R. It is the first step. Afterwards we can evaluate this part, friends, which is second step. They are basic concepts where students often get confused. Okay. Yes, Vanati, yes. Is it clear, everyone? Right. It is the first concept where you have to focus. Okay. And the second one, friends, let me see chart box. Clear, right? Okay. The second important point you have to remember, how can we read P implies Q? It is the most important statement, friends, because there is one previous paper GATE question. Most of the students are getting confusion about answer about that question, friends. Okay, we'll discuss that question now. How do you read P implies Q, friends? Okay, one way of reading this statement is P implies Q. P implies Q. Okay, and the second way of reading this statement is if P, then Q. If P, then Q, friends. Okay, and the third way of reading this statement is P only if Q. P only if Q. It is another way of reading this statement. And fourth way of reading this statement, it is the first one, it is second one, it is third one, friends. Fourth way of reading this statement, P is sufficient for Q. P is sufficient for Q. Clear? So with respect to P, these are the four ways we can read this statement, friends. P implies Q, if P then Q, P only if Q, P is sufficient for Q. So with respect to P, we can read like this. Of course, we can also say P is called hypothesis and Q is called conclusion. Okay, P is hypothesis, Q is conclusion. It is another way of reading this statement, friends. Okay, so another way of reading this statement is P is antecedent, P is antecedent, Q is consequent. Q is consequent. Clear? The next one is most important point, friends. Okay, here students are getting confusion. Please listen. So with respect to P, we can read like this. But if you want to start with respect to Q, you can also read like this, friends. Q if P. Clear? Q if P, friends. We can write like this, Q if P. And we can also say it is Q is necessary. Q is necessary for P. Q is necessary for P. Okay. So what else we can read, friends? That's all. I covered almost all models. We can also read Q provided by P. Okay, but we never use the terminology anywhere. So what is the importance of learning the terminology of P implies Q? We'll discuss some important problems. We'll get more clarity. Okay, if possible, you can write it down, friends. We'll discuss some problems. Okay. No, Nishukumar, we cannot write Q if and only if. Right. What is the necessity of writing these statements? Okay. We'll discuss problems. We'll get more clarity, friends. Right. Before that, you have to understand some important points. If you consider P implies Q, that P implies Q having converse is, that P implies Q is having converse is Q implies P, friends. Q implies P, and it is having inverse which is negation P implies negation Q. Okay, and it is having contrapositive, which is negation Q implies negation P. Negation implies negation P. Friends, in general, P implies Q always equivalent to its contrapositive. We frequently use this result. You have to remember this result, friends. Okay, these two are logical equivalent. P implies Q always equivalent to negation Q implies negation P. Clear, friends? Now by using these important basic concepts, how we are going to solve the problems. Okay. Yes, friends, this is the problem where most of the students are getting confusion, friends. We'll discuss this problem now. Okay, could you please post your answer in this chat box? We'll discuss this problem now. Okay, kindly post your answer in the chat box for this question. Yes, statement and contrapositive are equivalent. Could you please post your answer in the chat box, friends? Please post answer for this chat box. Please, everybody, please post your answer in the chat box, friends, because most of the students are getting confusion about this problem. That's why I'm discussing this statement. So some of you are giving answer is option C. Some of you are giving answer is option A. So why confusion? Right. Let me discuss this, friends. Okay. I stay only if you go. I stay only if you go, friends. The statement is I stay only if you go. Okay. Come back to the statement. See, A only if B. A only if B can be written as A implies B. A only if B can be written as A implies B. Please listen properly, friends. Okay. A only B. A only if B can be written as A implies B. So clearly the statement is looking like this. See here, it is only if I can say it is something like A, it is B. So it is having structure is A implies B. Correct. Now what did they ask question for this one? Converse of B. Converse of the statement. What is the converse of the statement? It is a given statement and its converse is B implies A. Converse is B implies A. Okay. Now remember this. Now come back to here, friends. A implies B can also be written as B if A. Right? A implies B can also be written as B if A. It is called antecedent. It is called consequent. Right? Okay. Consequent if A. Consequent if A. Here what is consequent, friends? Consequent is A. Correct? Consequent is A. So therefore A if antecedent, what is antecedent? B. So therefore we can say it is B. Please listen properly. A implies B can be written as B if A. Instead of understand B if A, we can say consequent if antecedent. Consequent if antecedent. What is consequent here? A. So consequent if antecedent means B. Clear? A if B. Now tell me what is A here, friends? I stay. I stay. A means here I stay. I stay. We can write if as it is. What is B, friends? You go. I stay. What is B? You go. Clear, friends? Now find the answer now. I stay if you go. Clearly it is I stay if you go. So the correct answer is option is correct answer. Okay. I hope you really enjoyed this question, right? If you really like this explanation, please type clear in the chat box. I'm losing energy, so I have to get motivated by you, friends, by looking at your chat box message only. Okay. Is it clear, friends? Type in the chat box. Interesting, right? You always write consequent if antecedent. Thank you, Shekhar, Ali, Raje, Rakesh Raj, Unnati, Nishu Kumar, Naik. Shall I explain one more? Probably you'll get more clarity about this kind of topic. Okay. Right. Actually, size of this very big actually. Okay. Please try to adjust. Yeah. Can you look at this statement, friends, and can you write propositional logic statement? I provided 4 propositions. One is A, B, C, D. I'm expecting propositional logic statement for this one. I won't see the lunar eclipse if I don't get up early in this morning. Okay. I won't see the lunar eclipse if I don't get up early this morning. Just write the propositional logic statement for the given statement, friends. Okay. Can you try? Write propositional logic statement for this. Please try, friends. Yes, Abhay Garg, it is correct. Friends, recall previous one which I explained, A implies B. Please recall it, friends. See, if I have P implies Q, one way of writing this statement is if P then Q, right? It is one way of writing this statement, if P then Q, or else we can also write P only if Q, P only if Q. Other way of writing this statement is Q if P, correct? Q if P. Now look at this statement, friends. Here we are having if, so therefore it is first statement, first proposition they provided, and it is second proposition they provided, right, friends? Okay, if I consider it is if, it is looking like this: Q if P format. If it is Q if P format, who is the antecedent here? Antecedent is P. Who is the consequent? Consequent is Q. So antecedent must be this one, friends. Antecedent must be this one. So I don't get up early in this morning is antecedent. Therefore this one implies, okay, antecedent implies consequent. So how we are going to write? I don't get up early in this morning. I don't get up early in this morning means I will get up early in this morning denoted by A. I don't get up early in this morning, we can define it as negation A, correct? Negation A. So this statement is completed. Please observe clearly. P implies Q means Q if P, right? If I write Q if P, P is called antecedent. So what is antecedent? It is called antecedent now. So I don't get up early in this morning, that is negation A, implies I won't see the lunar eclipse. I will see the lunar eclipse denoted by D. I won't see the lunar eclipse denoted by negation D. So it is negation D. This is the equivalent propositional logic statement, friends. Let me see how many of you answer this question. Yes, Komal Kumar, it is correct. Nishu Kumar, it is correct. Is it clear, everybody? Negation A implies negation D. Right. I hope you understand the importance of learning basic concept of P implies Q. Most of the students are getting confusion about P implies Q. Okay, it is compulsory. You have to remember this terminology. Okay. Shall I go to next problem? Friends, any problem are you facing in this question? Clear, right? Thank you, Agarwal, Ali, Shaurya Agarwal. Let me discuss one more problem, friends. Okay. Yes, I provided 4 propositions here. I'm asking if I get up early this morning, but it's cloudy outside, I won't see the lunar eclipse. How we are going to convert in terms of propositional logic sentence? Okay. Please observe how they are going to start here. They started with if. Please recall basic concept. If P then Q format. Please post your answer, friends. Yes, Shaurya Agrawal, it is correct. It is correct. Yes, Abhay Garg, it is correct. Thanks for your response, Abhay Garg. Shaurya Agrawal. Right friends, see here, it is starting with if, right? Okay, as I mentioned earlier, P implies Q can be written as if P then Q format, right? If P then Q format. So whatever is there after if, that is treated as P in this case. Okay, so I get up early in this morning. I get up early in this morning. So I get up early in this morning, we can define it as A, friends. So therefore A. See, in proportional logic, remember, if anything separated by comma and starting with but, you have to indicate with and operator, friends. Okay, you have to use and operator. Remember that. Suppose if I write P comma something like but Q, we can write it as this is equivalent to P and Q, friends. Okay, remember this basic concept, P and Q. Okay, so therefore, but it is cloudy outside. Here they mention there is there are no clouds in the sky. There are no clouds in the sky, it is C. There is a cloudy in the outside, means obviously it is negation C, friends. Negation C. Why did I write conjunction? Because here it is separated by comma with but. So that but indicates that you have to use and symbol, friends. Okay. And afterwards, I won't see the lunar eclipse. I won't see the lunar eclipse. Since it is starting with if here, so this is one statement. Okay. Implies I won't see the lunar eclipse. That is, I will see the lunar eclipse denoted by D. I won't see the lunar eclipse means negation D. Okay. How can you understand we have to use implication symbol here? The reason is here they mentioned if. Okay. So by using this condition only I have written this statement. Okay. That's all. Any questions, friends? Here I introduce some new concept is P comma but Q is nothing but P and Q. Okay. Is it clear? Right. Right. Look at this statement, friends. Verify is this statement is clear or not. Means what I am trying to ask you. There is a statement I provided, and for that I have written first order logic statement. Verify is this first order logic statement is correct or not for the given statement. Agrawal, they will provide suitable options. According to the options only they will ask. Okay, they will provide suitable options definitely. So there is a tall tree that is a sequoia. Sequoia is a redwood tree in California, friends. Okay, in California we can often see redwood tree. Its name is sequoia, redwood tree. Tell me, friends, is it correct? There is a tall tree that is a sequoia. Here I am going to introduce one important basic concept. It is a concept series, right? Therefore I am going to introduce most important concept now. Okay, but before that, please comment your answer in the chat box. Is it correct or not? There is no meaning for reverse exist. Okay, right. Look at here, friends. Its meaning is there is a tall tree that is a sequoia. That is statement. I want to make this statement is true. There is a tall tree. There is a tall tree that is a sequoia. So generally existential quantifier is used for at least one. At least one. They define like this. Please observe, friends, here. This is called predicate. Predicate. And it is called subject, friends. It is called subject. Means T is a subject and a predicate describes the properties of that subject. Okay, T is a subject where predicate describe the property of that subject. For example, friends, if I define D stands for Dhoni and S stands for, S is a predicate, that is sportsman. sportsman. If I define like this, now if I combine first order statement like this, S of D, it is nothing but D stands for Dhoni. Dhoni is a sportsman. You have to read like this. Dhoni is a sportsman. Dhoni is a sportsman. So this predicate explain properties of subject. Subject is here Dhoni. What are the attributes or properties? He is a sportsman. Clear? In this case, I created one first order logic statement with only single variable. Sometimes, for example, friends, if I want to write x less than y, x less than y. In this case, we are having two subjects. First subject is x, second subject is y. What is the property or what is the attribute between these two means less than. Suppose if I denote with L, then we can write like this, at predicate followed by two subjects. How you are going to read this statement? X is less than y. X is less than y. Clear, friends? This is the way we are going to construct the statements. Please observe these basic concepts now. Now by using this, in this case, friends, there is a tall tree. There is a tall tree. Observe how we are going to read here. T is a tree. T is a subject and its property is tree. How many such trees? At least one tree. At least one tree. There exists tree means at least one tree. Okay. And that a tree is T is tall tree also. Okay, tall tree also. Then it must be sequoia. It must be sequoia. Friends, in this case, why it is not suitable statement for the given statement? Everybody listen, please. Everybody listen. What is the meaning of the statement? There is a tall tree that is a sequoia. There is a tall tree that is sequoia. For example, friends, there is a forest. There is a forest. Assume that there are group of trees. There is a group of trees, and none of them is tall. None of them is tall. Clear? None of them is tall. All are short trees. All are short trees. In that case, friends, in this universe of domain, if I apply this statement, so I am going to pick up T. I am going to pick up T, where T is a tree. So T is a tree. Yes, true. T is a tree. True. And T is tall. No, T is not tall. T is short tree. So it is false. False. Right? Implies sequoia of T. So assume that is sequoia of tree only. These are sequoia of tree. Okay. So it is true. These are sequoia trees which are short trees. These are sequoia trees which are short trees. Now look at what is the overall statement conclusion here. True and false implies true. So since we are having parenthesis here, therefore this part will be evaluated first, right? So false implies true, result is true. Result is true. Now true and true, result is true. It means that the first order logic statement which you constructed is true even though there does not exist a tall sequoia. Even though there does not exist a tall sequoia, your first order logic statement is true. That is the reason it is not the correct way of representing this problem. I'm repeating once again. Actually, if you write the statement like this, the problem is even if tall sequoia does not exist, in that case also the whole first order logic statement is true. That's what I have taken. I consider a domain, that a domain contain all sequoia trees. Assume that all are short trees. All are short trees. In that case, if I pick up one short tree, if I substitute here, T is a tree, yes, and T is a tall, no, that's a false. Is it a sequoia tree? Yes, which is true. But according to implication notation, false implies true, always true. Now true and true, always true. So even though there does not exist a tall sequoia, your first order logic statement is giving result is true. But actually what we are expecting at least one sequoia tree which is tall. See, there is a tall tree that is sequoia. So for this statement, if you could construct like this, definitely you are getting wrong interpretation. Then how you are going to construct? Important logic, friends, please listen. Whenever we are using existential quantifier, it is compulsory you have to combine with conjunction only, not with the help of implication. It means that the correct way of writing, look at here, friends. See, this statement obviously it is giving problem, right? That's what I explained here, previous one. Sorry. Okay. What is the correct way of writing this statement, friends? The correct way of writing this statement is, here we are facing problem, right? Okay. So there exists T of T and tall of T and sequoia of T. In this case, friends, if we consider a domain which contains all our short trees, on that domain this statement is giving false, so that we can say it is a correct statement for the given problem. You are saying that there is a tall tree, that is a sequoia. If you consider a domain with a short tree, in that case obviously this statement is giving false, because tall of tree is false, false into something, obviously it is false. It is a correct way of writing, it is wrong way of representation. Okay, is it clear, everybody? Why there exists is using always why there exists is using always conjunction? Yeah, discrete mathematics mass you can expect 8 to 10 mass, Unnati. By combining engineering mathematics you can expect 15 to 16. Friends, is it clear, everybody? Right, if it is clear, the next important point here, friends, see, every tall tree is a sequoia. Every tall tree is a sequoia. In that case, friends, see, here we are using universal quantifier. Universal quantifier. So you are choosing subject is a tree, right, and it is a tall tree. How many such trees? Every tree. If these two properties are satisfied, then definitely sequoia of tree. So here the important point is here, friends, for all always using implication, if you place them in the parenthesis. Why you want to put them in the parenthesis? Because order of precedency. What is the order of precedency? Conjunction is having high precedency over implication. Conjunction is having high precedency over implication. Clear, friends? Conjunction is having high precedency over implication. Therefore, if I keep them within the parenthesis like this, okay, so it is one proposition implies another proposition, so we can keep outside parenthesis like this. Now as a student you have to understand, it is not required. So whenever we are using for all symbol, it is always using implication. Whenever we are using existential quantifier, it is always using conjunction. Clear, friends? So if you remember these points, we can easily answer gate questions based on these two topics, friends. Okay, can we start questions based on these two topics? Clear, right? Yes. Let me go back to the previous paper gate questions, friends. We'll get more clarity. Right. So it is one of the gate question they asked here. All rainy days are cold. All rainy days are cold. Can you answer this one, friends? All rainy days are cold. Let me see chat box. Yes. Sorry, not all rainy days are cold here. Not all rainy days are cold. Not all rainy days are cold. I didn't read in properly. not all rainy days are cold. See friends, whenever they are using not before all, okay, before all, so what you will do, first ignore that not and try to construct first order logic statement for this one, friends. All rainy days are cold. All rainy days are cold means according to given statement I can say D is subject whose property is rainy day, okay, rainy day. Clear friends? How many rainy days? All rainy days. All rainy days, therefore we can say for all D. But whenever we are having for all symbol, we have to use implication. We have to use implication as per our previous concept analysis, okay. Or cold. Cold we are defining it as COLD of D. It indicates that all rainy days are cold. Clear? But here the mentioned is not, therefore we can use negation, friends. We can use negation. So the moment if you use negation, negation of for all will be converted as there exist. These are basic concepts, friends. Please remember. Okay. Negation of for all can be converted as there exist. There exist D. Clear? So here we are having negation of this total part, friends. How we are going to write this total part? According to basic concept, P implies Q always equivalent to negation P or Q. Negation P or Q. So therefore we can write negation rainy day or cold day. Cold day. Right friends? Now expand negation inside, we'll have there exists D. Negation get cancel, we'll have rainy day. When you take negation inside, so disjunction becomes conjunction and negation of cold of D. Negation of cold of D. Clear friends? So this is the way you have to understand the problem. So answer is option D is correct answer. Any doubts, friends? Yes, D is correct. Friends, you have to remember this, in many places we are using this notation. Please observe this one. Just observe this one, friends. Whenever we are having negation for all x, A of x implies B of x. Going forward we are going to discuss many problems. In that case this is equivalent to, friends, directly we can say there exists x A of x and negation B of x. Many places we are using, therefore every time it is not required to write this statement like this, okay. So whenever we see negation of for all x A of x implies B of x means there exists x A of x and negation B of x. Okay. Try to remember this one, friends. Okay. Let me discuss next problem. Alright, it is also one of the gate question, friends. Okay. Not all that glitters is gold. Please post your answer in the chat box. Not all that glitters is gold. It is same as previous one only, right friends? Actually what we have to write? First we have to write for all x which is glitter of x. Universal quantifier always using implication which is gold of x. So it is a first order logic for all that glitters is gold. But whenever we are using not symbol we have to use negation now. So that is negation. Just now I explained negation of for all x. If you see like this directly answer we can write there exists x glitter of x and negation of gold of x. Just now we evaluated, right friends? Okay. So what is the correct answer now? There exists x glitter of x and negation of gold of x. Yes. Option D is correct, friends. Okay. What is your answer?